Rangaramya ma'am, CSD HOD, to introduce the chief guest.
Sir, good morning, sir. Sang Won sir. Hope you remember us. Welcome to RMK in virtual mode. It's my pleasure in introducing the guest of the day. Sang Won sir is a professor and is a recipient of the Sunny Chancellor's Award for Excellence in Scholarship and Creative Activities in 2019, and highly successful researcher who leads many productive long-term industry collaborations. Professor Yoon received his doctoral degree in School of Industrial Engineering at Purdue University, and he joined the faculty of the Western Watson School in the Department of Systems Science and Industrial Engineering at State University of New York in Binghamton in 2010. Professor Yoon is currently a professor in addition. He has a joint title in School of Commerce at Waseda University, Tokyo, Japan, and is also visiting professor in Nirma University, Ahmedabad, India. Professor Yoon directs the Complex System Design and Analysis Laboratory, faculty member of the Watson University for Systems Excellence. He leads collaborations with faculty, staff, students, and industry partners such as Analog Devices, Samsung, Sanmia, SEI, and it's my pleasure in welcoming you sir, for today's session. Over to you, sir. Thank you.
Okay, I hope you guys can hear me. Let me put the slideshow mode. Do you see my slide okay?
Yes, sir, it's visible.
Okay. So I'm gonna present this one in the slideshow mode. So I may not be able to check out the chat window. So in case you have any question during my presentation, please type in your question in the chat box, and I'll try to address all the questions after my presentation. Okay.
Sure, sir. You're loud and clear, sir. Thank you, sir.
Okay, so the title of this talk is slightly different from the the brochure that you guys must have. So this is a digital transformation using AI machine learning in the electronics manufacturing. So we have done a lot of the smart manufacturing concept in the electronics manufacturing. So under the Industry 4.0 concept, I would like to highlight the electronics manufacturing as one of the Industry 4.0 application. Okay. So this is a slide that I like to use it as an intro of my talk. So what will be the driving force of the Industry 4.0? So a lot of people talk about the Industry 4.0 many different ways. So I would like you to actually focus on this figure first. Let me change the pointer. So in this figure, so we do have Industry 4.0. So there are many discussion about the Industry 4.0, how to define the Industry 4.0. But nobody will argue that the Industry 4.0 will be the combination of the many different technology that the mankind has developed, the many decades. Okay, so robotic, Internet of Things, and Internet of Things in simple term, it's gonna be sensors and different type of sensors, simulation, big data, cloud computing, system integration, cybersecurity, and etc., etc. So there are many things that out there. Maybe like this is not everything about the every technology or every method that we are going to use under the Industry 4.0 concept. So, but this is just some example. So we have to integrate so many different technology and so many different data methods and whatnot. So how we can actually integrate everything together and make the one voice so that we can control the factory or the warehouse without human being there. So AI, machine learning algorithm, AI method, maybe the backbone of the Industry 4.0. So all this technology, if you look at the individual technology, robotic and Internet of Things, and then simulation and system integration, and all these things, individual item has been developed many decades. But Industry 4.0 concept requires the consolidating everything. So AI may be the one that who can help us. And then if you look at this chart, so AI and the machine learning is not new. AI concept was introduced in the 1950s, and the machine learning algorithm introduced in the 1980s. The question is, AI was there, robotics was there, and then all the sensors and big data was there. But while we are talking about the Industry 4.0 now, maybe past a decade. So if you look at this chart, so this can answer those questions. So for example, cost of the data handling compared to the 2004 and 2014 is 98% cheaper, as an example. And if you look at the 2022, probably compared to the 2004, maybe it's 99 or more than 99% cheaper. And if you look at the cost of the bandwidth, and this is the telecommunication channels and whatnot, so it's 80% cheaper compared to the 2015 and 2020. But if you look at the 2022, maybe it's even cheaper than that. Cost of hardware in 5 years, it's only the half price. So mobile devices has been increasing. Adaptation of the mobile device has been increasing. So all these hardware changes and all those things, perhaps that make us realize that maybe it's time that we can realize the Industry 4.0 with help of the AI machine learning algorithm. So that's kind of the area that I believe that we're living. Okay. Under that, so I'm not sure how many people understand the smart electronics manufacturing. So if you look at the Nissan news, and US will be bringing a lot of the semiconductor industry back to US. And then the electronics manufacturing that I'm about to talk about is not the front end of the semiconductor. So which is, I think I'm going to talk about the PCB assembly line, which is a back end of the semiconductor process. As an example, so wafer manufacturing or the die design will be the starting of the semiconductor business. After the die is built, and we have to package it with the different wires, bonding and whatnot. And after that, we have to put those chips over the PCB board, and then those PCB board goes to the consumer product like Apple Watch, iPhone, Galaxy, and whatever. So what I'm about to talk about in today's talk is talking about how to apply the Industry 4.0 concept mainly in the PCB assembly line. But I believe that this kind of the concept can be applied to the many different industries. So I hope that you can project this kind of concept and technology can be applied to the many different manufacturing with the Industry 4.0 concept. So under that, I'll introduce the smart electronics manufacturing concept and AI-based closed-loop control. And after that, I have 3 main topics that I'm gonna talk about. So one is online, offline control of the stencil printing process and how to apply the AI machine learning algorithm. Second topic is a mounter, how to select the optimal position of the component, because a mounter has some sort of the deviation from the center, how to pick up the good location and then make sure that the components stay in the center of the pad. And then finally, there's a reflow, how to optimize the reflow. So in short, in terms of the PCB assembly line is consisting of the 3 elements, which is stencil printing, mounting, and reflow. So I'm talk about all those things, and after that, I'll talk about the future of this kind of the PCB assembly line or the smart electronics manufacturing factory. So that will be the conclusion of today's talk. So this is the concept of the smart electronics manufacturing. So we like to make a manufacturing system much more intelligent. So in our campus, I'm coming from the State University of New York at Binghamton. So we do have a smart electronics manufacturing lab. And smart electronics manufacturing lab consists of all this kind of the equipments. I believe they're combining all this equipment together. I think we're looking at around 1.5 to the $2 million worth of the equipments. So we do have a functional PCB assembly line. So let me talk about this one. Around 2016, we established this lab. So there's a 2 stencil printer, one from Accra in German, and another machine, NPM, from the Boston, US. And then we have 2 printer. And then we have a SPI machine, which is inspection machine. And then we have 2 types of the mounter. One is universal, and the other one is a Fuji high-speed mounter. And then another inspection machine, it's called automated optical inspection machine. And then reflow oven, and another post automated optical inspection machine. So this is a typical PCB assembly line. Only difference is probably the printer, most of the time they are using only one, and mounter, depending on the number of components they have to place on the PC board, and many times like you will see a series of the mounters, chip mounters, okay? So that's kind of the other line that you're seeing it. So our students are printing and then testing, and also the create the smart electronics manufacturing solution. As an example, let me briefly explain it. So we have actually the study, the printer side of the study, and then mounter side of the study. And since 2022, and then we've been studying the reflow. At the moment, and we are trying to combine the different data together and optimize the different part of the PCB assembly line. In short, I have a next slide and I can explain this one a little better. So we are developing the cross-loop feedback control system. So as an example, so the stencil printer will print it. And then this one will go to the SPI machine. And SPI machine will inspect the quality of the stencil printing. So in Industry 4.0 concept, who's the controller? Who should be the controller? That's the question that you can ask. The SPI machine is inspection machine. So we will know what are the setting of the stencil printer, and then the result of the stencil printer. So the inspection machine perhaps will contain the most of the data. And then we do have a 3 inspection machine in this line, SPI, and then 2 AUI machines and whatnot. Okay, so using this inspection machine, can we have a cross-loop feedback control system? So printed, PC board is coming to the SPI machine, and then we gather the data, and using this data, we control the machine and new parameters. In terms of mounter, we have SPI and AUI information, and then gather the data and control the mounter setting. And then reflow, once we have a pre and AUI information, and based on this information, can we optimize the reflow setting? So those are kind of the concept, and I'll have a more detailed slide and I'll talk about it. By doing that, we can improve the yield and minimize the defect, and we can also have a real-time control system. Okay, and then I'll walk you through what type of research that we have done in this domain. So before that, so this is a kind of the eye chart of our lab, what kind of the PC board, and then what kind of the soda paste, and what kind of the plate, and what kind of the components that we are using here. So this is a kind of the summary. So we do have many different testing vehicles. And then we tested more than actually the 10,000 PC board as of now. So if you look at the stencil printing, so this is another eye chart. So there's a stencil, okay, and then there's a soda paste, and then printer setup, and then printing machine. So printing setup and the printing machine is a soda paste, or the stencil printing is what I'm talking about. And then there's an environmental factor. So for example, humidity, and then temperature, and airflow, and then human factor. Those are the things that we may not be able to control. Okay, as an example, because it's keep on changing it. And the stencil, before you go to the manufacturing, and usually the type of a stencil, or the coating, laser coating, or the nano coating, and then different type of stencil, all those things are decided already. So during the production or during the manufacturing, we're not gonna make changes on the stencil. If there's a worn out stencil, we may replace it, but we're not gonna change the characteristic of the stencil. In terms of solder paste, it's the same thing. Solder paste is also the important part of the puzzle, but the viscosity and then particle size and all that. So solder paste is decided. And once they manufacturing system decide to use the different type of the solder paste, they stay with it, okay? And then machine, you cannot easily replace the machine. So if you look at the entire sensor printing factors, and printer setup is the only thing that we can control as a part of the intelligent manufacturing, okay? So there's a squeeze pressure, speed, and printing direction, and snap of distance and separation speed. So as an example, and snap of distance is based on the multiple, so many iteration and of the experiments, we know what is the required step of distance. So and then it doesn't vary much depending on the different stencil and solder paste, and we know that. So if you look at the this one, and squeeze pressure and speed will be the most critical. Printing direction is sometimes you can print it as a forward and backward. Depending on the different direction, you may have a different optimal setting. So technically, we control 3 settings: squeeze pressure and speed and separation speed. So those are the 3 things that we control, and depending on the different printing direction, and we have to optimize it, okay? And then also in terms of the PCB assembly line, about the 70% of the PCB assembly defect and errors are coming from the printing. So the printing is one of the important step. So let me explain the AI machine learning based the crossover feedback control system one more time. So we are going to apply the AI machine learning algorithm. So we are developing an AI machine learning algorithm, and the AI machine learning algorithm will be embedded in the inspection machine. So here, and here, okay? And then once the result is coming into the this machine, data is PC board is coming to this one, and then we inspect it, and the inspection result goes to the AI machine learning engine, and then we provide the better setting as needed, okay? Because this is a production line, and we're looking at the CPK, CPKM, offset, and defect, and all those things are factors, all the metrics, okay? So based on the real-time control, and then we want to do it. So in here, so let me explain this one, the 3 things. The PAM is our concept of the offline control. So for example, before you go to the manufacturing and you want to identify the what is the optimal setting, so this PAM will give us the offline optimal solution. And then POM is online optimizer. So before you start the manufacturing system, and based on some DOE and sample data collection, and we can optimize the setting. That's a PAM. And then POM is once we start doing the manufacturing, we can collect the real-time data and then make some adjustment. So that's the online, okay? PDM is the diagnostic module. So which means we don't want to have not so good data coming into the AI machine learning engine. So this one, PDM, is checking out the abnormal behavior of the system, or the data is the abnormal. Then we don't want to add this one to the AI machine learning engine. Instead, we can actually filter them out, or we can detect the root cause of the problem and then do that. Okay, so I spend a little bit more time on the printer side because the other side is the same thing. So mounter, we are going to have a offline control and online control and diagnostic module, but offline control is more like a calibration of the machine, because this chip mounted machine will pick up the component and move the component and place them on the PCB board, printed circuit board, okay? So that's a calibration is offline control. And then we are interested in online control, and then MDM, which is a diagnostic module. So leaf-Loven, I have a separate slide, and I'll explain this one in the later slide. Okay. So I think this is I spend a little more time and I explain this one, but the other slide I can go a little bit quickly. So online, offline, and diagnostic module. So you can see offline control, online control, and diagnostic module. And you collect the data from the printer, and then SPI machine will give us a feedback control and collect the data, feedback control. Okay. So what we are trying to do is based on that. Let's say when you collect the data out of the inspection machines, and you see a lot of deviation of the outcome, and then we want to have a shorter deviation, and also that there's a target volume of the stencil printing result. Let's say this is 100% is a target, and typically industry allowed to accept, plus minus like 30% or the plus minus 50%. As an example, 70 to 130. If you want to have a little bit tighter control, then 70 and then 130% of the printing volume will be accepted. And if you relax, and 50 to 150 will be collected. So if you want to have a tighter control, and then you probably will need to have this kind of the controlling system. Another way that you can do is you can have a real expert of the sort of printing engineer and stay next to the line. But if you're looking at the Foxconn, Samsung, like a Bosch, I mean, all the big company, they have maybe hundreds of this kind of line, and you cannot have those engineers stay in next to the every line. So that's why we want to create this kind of smart system, smart intelligent AI machine learning based system, so that we can mimic what expert can do without having them on in the line. Okay, by doing that, we can achieve so many different benefits. Reliability will increase, consistency, and then will minimize the defect, and then improve the yield and then efficiency. Okay. So we actually have, we developed the AI machine learning algorithm, and then I'm just showing you the results. So let's say there is a PCB board. Okay, so we've been partnering with some company, and then they actually brought us the automotive PCB board. And this is the engineer suggested. So you need to use the squeeze pressure as a 7.2, and speed is 50.8, and 1.3 as a separation speed. So those are the kind of the speed the Unity have. So this is their known optimal solution. Without teaching, without providing this information to the AI machine learning algorithm, and then our PEM come up with this solution, 6.0, 60.5, and then 5. So those kind of the result that we got. And then based on, and then we actually tested in the same line, same PCB assembly line, and with this setting, okay, customers best known, and then our AI machine learning algorithm solution, and it turned out then CPK is improving about 56%, and then this is another test. So we see significant improvement from the customer best known, and then AI based solution. Another thing that I like to highlight it, speed. So if you compare the customer's best known solution and versus this one, this is a little higher pressure and a little less speed. But if you look at this one, AI is suggesting a little bit faster speed. So that means technically with the same amount of time, and then you can produce the more PCB board, because the speed is slightly higher, maybe like 10%, 20% faster. Okay, so that's kind of another benefit that we are going to get it out of it. Okay, and this is the actual testing result. So this is another eye chart. So let me show you this one. So this orange line is indicating before this one is a PEM, and after this one is the POM. So we collect the DOE data, design of the experimental data, and then optimize it. So this is what's happening. So CPK will be improving based on the number of data that you're collecting. After that, online data comes in. So when you're receiving the more data, it's not always guaranteed that your result is going up. So sometimes CPK coming down and coming up and whatnot, but ultimately we like to achieve the higher CPK. Okay, so in order to test it, this kind of environment, we cannot always do the printing. So we actually developed the bit of the digital twin concept. So how can we develop the stencil printing in the virtual environment so that we can actually do so many different iteration and come up with the solution? So in this case, we kind of divide the signal as a two piece. One is the true signal, and the other one is the noisy signal. And by combining them together, and we always keep on changing the noisy signal. So whenever we got the different solution, and we can test it. So this is kind of the one method. And another thing is if you look at this one, so maybe like a CPK improvement is you can sometimes drop it and sometimes it's going up. But the question is, how often do you want to make a changes on the mechanical setting, like a printing speed and then pressures and whatnot. So it's not easy to make a changes like every iteration. So we are going to check it. So maybe like a printing setting is doesn't change it much between this and that, as an example. Then even though we maybe improve the CPK slightly and we don't want to make a changes, but if we see the true optimal signal, while we are going through this kind of process, and then we are going to make a changes. Again, this is kind of the monitoring, and then we're not going to make a changes. We're not going to make a changes. But once we see the significant improvement from the one CPK to the other CPK, and then we are making changes, as an example. So this is kind of the illustration of the real-time optimization. Okay. So diagnosis, stencil printing diagnosis. So we have done a few things. So abnormality detection and cleaning frequency and then cleaning profile. So as an example, because we're using stencil have a soda paste above, and then it will squeeze, and then soda paste will come out in the through hole and place on the PCB. And because there's also snap up, and then there's a little bit of short distance between the PCB and then the stencil, and bottom of the stencil, it will create some residuals, soda paste residuals every once in a while, and then you have to clean it. This is one of the big issue. So how often you want to clean bottom of the stencil? What type of the cleaning profile do you want to have it? Sometimes you have to clean it with the dry. Sometimes you have to clean it with a wet. So as an example, let's say you are cleaning up your house, and you can just mop it and then broom it with a dry method. It's gonna make your room clean. But if you want to make it super clean, maybe you can use the water, okay, to clean up your room, and then your room will be much cleaner. So there's a different type of cleaning, dry and wet, and this is frequency. And then also, if there's any kind of the abnormality behavior, we like to detect it. So this is kind of the 3 module that we have. So as an example, we got the sample data, and then we apply the deep learning method. And then this is sort of the PCB board, and you can see it. So we know there's a lot of sort of low soda paste and then braid defects. And then there are 9 different kind of the root causes. And if you apply the exception network method, and then we're able to identify the 82% accuracy, percent of the accuracy, saying that this is one of this kind of error. But if you have 6 classes, and then we can identify about 86.79% of the defects. Because we do not have a lot of data when we apply this one. But imagine when we are applying this one in the actual manufacturing line, and we're gonna collect the more data. I believe the exception network or any deep learning method will perform better. Okay. So this is what I mentioned to you about the cleaning. So let's say look at the stencil, and bottom of the stencil, you can see a lot of the clogs and residual building up at the bottom of the stencil. Actually, this is the photo taken by the students. So here's another picture. So you have a stencil, you have PC board, and then through all technology, we're putting this one. And after that, we snap up, and then the stencil will be lifted up from the PC board. Then you can see like there's some kind of residual and sticking in. And then we have to clean up this one every once in a while. So the main idea that we have here is, so we actually took up the older photos, and then as you can see here, but in order to take a photo, if you take a photo and then detect it, oh, there's a residual, let's clean it. So the question becomes, how long does it take to take a photo? For example, if you printed one PCB board, you may take maybe like a 14-second or 15-second or something like that, less than 20 seconds as an example. But if you take a photo with a high resolution and process the image file and then doing something, it will take a couple minutes. So that means if you take a photo of the bottom of the stencil and provide some kind of the solution, and it will not work, as an example. Okay, so our idea is, why don't we estimate the amount of the residuals building up? So we build the algorithm, long-term, short-term memory-based algorithm, and we estimate the amount of the residuals building up, and then based on that, and we can decide it what kind of the cleaning frequency and then cleaning cycle that we have to do. So that's kind of the study that we have done it. Okay. And here's another thing. So if you look at the assembly line, so think about it, one PC board goes to the printer, and then this PC board will go to the inspection machine, while one machine is going to the next machine, and then the previous machine, the printer will receive the next PC board. So which means if you predict what kind of the setting that you have to change it in one board after, it will not work, as an example. So if you print it, if you receive the data and then predict it, you have to predict it 2 board after. So meaning you're not predicting, let's say you're making a line. So as an example, let's say you're making a line. So it's one guy is being served, and then there's another guy is also being served. So by the time you receive the data and then identify the another optimal setting, you cannot apply this one because it's too late. So you have to apply this one is another guy, one guy after. So this is a kind of the illustration. So using 2 data, and this is the first one and second one, and you have to predict the behavior of the first one, because the third one is already too late, because this one is in the stencil printer, and then it's already printed. Using 3 data, we have to predict it, 5th one. And same thing, using 5 data, we have to predict it, 6th one, as an example. So this is kind of the study that we have done, and you can see the result here, okay? And then the bottom of the stencil, once we understand the bottom of stencil, and then another thing is a dry cleaning profile and a wet cleaning profile. So there are different features here. So volume averages, standard deviation, and defect warning and whatnot. So this is all the numerical data, but we like to use the some deep learning method. So student developed the based on this numerical data, we developed some kind of the image file. So this image file is illustrating certain type of volume, certain type of standard deviation and defects and whatnot. And we actually developed the stacking images with the RBG. And then based on this RBG file, and then she applied the some deep learning method, and then identify the do we need to use the dry cleaning and wet cleaning. So you may consider wet cleaning will clean up the bottom of the stencil much cleaner than the dry cleaning. Then you may actually question, okay, then why don't we actually use the wet cleaning all the time? Because of the timing. So manufacturing, the throughput is the most important thing. So dry cleaning doesn't require a lot of time. Let's say dry cleaning takes, let's say 30 seconds, but wet cleaning could take 2 minutes because you're using solvents, some alcohol, and then clean up. So you need to dry up those the solvent alcohol, so that those alcohol and solvent will not affect the soda joint, soda paste in the next iteration. So it takes longer time. So if you use the more wet cleaning, and you will delay, okay? And then cleaning itself is the delaying the throughput, but outside of out of the dry and the wet cleaning, and wet cleaning delay the process much longer, as an example. So we want to minimize the wet cleaning, and we want to minimize the dry cleaning as much as possible. So we developed the optimal cleaning profile selection and optimal cleaning cycle selection model, and then combining cleaning cycle and then profile together. Okay, so this is a kind of the example. So we got the board from some company, and then applying our cleaning profile solution, and then we are able to improve the CPK around 13%. Okay, so moving on to the mounter. Give me 1 second. Looks like there's some chat box. Okay. Okay, so I don't think we have much time. So let me quickly explain this one. So the mounter study, same thing. So I explained this one before. So we have an online setting, and then the diagnostic module. So in short, maybe I can explain that this one, the entire concept of this one with this slide. So there is a pad and there is the soda paste, and these two things are usually misaligned. Okay, and so many reasons. And after that, you have to put the component. So if you look at the Fuji, Panasonic, like Universal, like the major chip mounted company, the default setting is to place the component on the center of the pad. Because the pad location is given from the job file, so you can easily place the components over that. Okay. And then the Panasonic have a pattern, which is the APC module. So what they're doing is, instead of putting the component on the center of the pad, and they like to put the component on the center of the paste, sort of paste. So that's kind of it's a pattern. So you can Google it and then Panasonic APC, and then you can find their solution. But our idea is, it may not be the center of the pad, it may not be center of the paste, it may be in between. But we don't know exact location, so this is what we are trying to find out. Okay, and then after that, we like to have this kind of the result. So this is showing the results. So let's highlight it. So blue is the placement location that we design it, and then red is a default setting, and then the green is the Panasonic result. So if you place the component in between, somewhere else, then finally after the reflow, and then components come to the center. So this black dot is coming to the center. So we can see this one from our experiments. And then there's also the software that who can actually do the similar work, which is called the Surface Eval. But we learned that the physical model or the numerical model not always providing the result from the actual experiments. So our data-driven model and then the Surface Eval model, and then doesn't give us the same answer. So our idea is perhaps that we have to use the data-driven model to train the physical model or the numerical model, or maybe like compensate some of the physical or the numerical model. So that was our concept. So let me just skip this one. And then, so the machine learning based online cross replacement control works like the same thing. So we have SPI data, and then we use the dynamic placements options and machine learning algorithm and decision making module, and then generate the alpha file so that the placement machine will listen to this alpha file and place it, meaning it's not going to place the center and slightly off, as an example. So that's kind of the concept of this one. By doing that, so this MOM is online, the mounted control will minimize the deviation like around 30% compared to the default, which means place the component on the center of the pad. Okay, that's an example. So I'm gonna skip this one. So in terms of the diagnostic module, so same concept compared to the printer. So we want to use the different diagnostic module. And here's example. So what about the nozzle size is a different, incorrect nozzle size? How can we optimize it? What about the pickup position is different from the center, and how we can do it? And then the nozzle contamination. What if there's a contamination on the nozzle, and how can you deal with it? Okay. So based on the multi-criteria output, like a classification module, and then we achieve the overall accuracy of about the 85%. But if you want to detect it like a single category classification model, like a nozzle size is 92, pickup position is 100%, and then contamination is 97%. So we also developed this module. So moving on, so this is I will probably spend another 2-3 minutes, and after that, if we have time, I'll spend another few minutes, and then I'll take some questions. So the recipe optimization. So this is the reflow oven. So if you look at the reflow oven, then there are different time zone. So this one is 100 Celsius, 140 Celsius, 155, and 270, something like that. Let's say this is a 6 zone. So the control parameter is a discrete parameter. So this is temperature 1, 2, 3, 4, 5, 6. So we have 6 different temperature. PC board is coming into the board and then flow down entire process, and then it will generate the joint. So our control parameter is a deterministic, but at output of the temperature on the PCB board, we'll have to follow this kind of the nonlinear line. So what kind of the temperature setting we have to have so that it's not the board temperature, the joint temperature. Sometimes if you look at the BGA QFP, the joint is under the component. Some of the BGA is very big. So the joint temperature has to follow the exact line. So how can we do that? Okay, so that's kind of our research question. And this is a kind of our oven, and then this is the kind of thermocouples, and then we do that. So our idea is this one. So we need to collect the data, but we want to minimize the number of data collection. So initial data collection is based on the heat transfer equation, like a simple heat transfer equation, and we collect we have some kind of the setting, and we collect the data, the one board. Typically, if you go to industry and then they collect a lot of data by doing this kind of the thermocouples. Okay, but we collect the one board, and out of the one board, and we develop the prediction model, and then we optimize the prediction model. Okay, so out of the one board, and then we develop the prediction model and then optimize it. So this is kind of the process that we're seeing it, and we can see that we can develop the prediction model almost like a 95% accuracy. R-scale value is 0.95, which is very high. Okay. And after that, after we have a prediction model, after that we are developing the what kind of the temperature setting that we have to have it. So depending on the different reflow oven, sometimes you have 6 zone and sometimes 7. I was told that you can have a 12 different temperature zone. So we can actually optimize it based on that. Okay. And then here's the result. So this is a target, and then this is a predicted. So target as we have engineers, and engineers believe that this should be the temperature that we have to use it for our test vehicle. And then the predicted one is this one. So which means it's a slightly higher in some of the places, especially the zone 6 is a higher. And after that there's a cooling. So and then the average gap is less than, plus minus, 2 or 5 or something like that. So that's kind of the gap. So the AI machine learning based algorithm will use only the one data points, one like PC board, the thermocouple flow, and then we collect the data, and based on that we can optimize it. Okay. And then we identify compared to these two, and then the AI based predicted and the result is actually performing better. And then this is something that we discovered recently, and compared to this one, because a higher temperature will increase the time above the liquidus, meaning make it so that joints are more liquid type. So which will create the better joint, which will create the better self-alignment. So we learned that the predicted module works better than the human decision. So in terms of the future integration, so again, we've been working on the printer and an SPI machine, and then mounter and an AOI machine, and then reflow to the post AOI machine. So this is kind of the single machine, or the maybe 2 inspection machine, like a cross feedback control system. So in the end, we like to actually put it this one. And then right now, there is some kind of the set-top box computer, like a GPU machine computer inside this inspection machine, and does all the control. But in the end, I would like to put everything in the high performance computing in the cloud system. And this is a one line, but if you look at the multiple line, it can be hundreds of the line. Then we can control all this system, the factory level system from the cloud-based intelligence platform. And this is what we are heading to. So let me explain our current research. As the last topic, our current research is from here, from the inspection result here, and we like to predict at the end of the line what will be the outcome of this one. Okay, and then same thing based on these two, and then we like to predict what will be the outcome of the end. So that's what we are interested in. Okay. So if we are completing this one, I think we should be improve the the smart manufacturing concept, like maybe 2 steps better than where we are now. Okay, and also a lot of things that I'm proposing today has been implemented with the sponsor company, and our solutions are sort of embedded in the line, and then a lot of the companies are using the solution that I am presenting today. Okay, so thank you very much, and I like to highlight the Dr. Wan. So Dr. Wan and myself are actually working on this project together. Currently, we have 4 students working on this project, and so far we actually published maybe like more than 20 papers out of this topic in the conference and journals and whatnot. And then 4 or 5 PhD students graduate from this topic, the topic that I'm presenting today. Okay, so I'll conclude my presentation here. And if you guys have any questions, and I'd like to answer.
Thank you, sir. Thank you for the wonderful speech, sir. Thank you so much.
Questions? Any questions from the participants?
Yes.
안녕하세요, 윤상원님. You hear me?
Yes, I can hear you. Yeah, thank you for speaking Korean to me.
Okay. So just thank you for a very informative talk on AI ML based closed loop control systems, intelligent sensor sensing, and sensor printing in virtual environment. So that's very interesting for me. So just a couple of questions. So one, these ML models, what you prepare, I mean, are they common for all the assembly lines, or do they need to be trained or calibrated for each assembly line?
Okay, that's a good question. So technically, depending on the different setups, so we have to training individually, because if you receive the new job file, new component, even the equipment is the same thing coming from the same vendor, then there are some different specifications, so we have to train it separately. So I believe that this is another topic. So this will take a time. So we are trying to come up with a solution which can transfer the knowledge between the one line to the other. That's what we are working on it. But for now, individual training, training for the individual lines. Sorry.
Okay, thank you. And related the second question. So this to train the models for your research, I mean, are there any open data sets available, or are you getting it in some partnership with some company?
We have a lab, so we are creating all the data by ourselves. And so we have actually the sponsor, the companies, and they provide all these equipments and whatnot. So our students are doing the experiments and creating the data, and also the developing a solution, and then testing the solution with the existing line. So it's not coming from the open source data. And sorry to tell you, but we cannot also share, because there's a lot of the company like proprietary information in it.
Okay, thank you very much.
Thank you.
Thank you all for listening. I'm glad to introduce our session chairman.
So we are moving to the next talk. So if you want to jump in, you can.
Oh, sure. I will stop sharing.
Thank you very much.
All right. Thank you, everybody, listening to my presentation.
We have our session chairman, Sri Ratnakar Rao. He is a senior director, Samsung R&D Institute in Bangalore, where he leads the Beyond 5G team. He has over 20 years of experience in telecommunication industry. He specializes in wireless protocols and played a key role in the launch of Samsung's 5G mmWave and standalone smartphones in worldwide markets. He is a senior member, IEEE, and has 25 plus international patent brands. His current areas of interest include AI in wireless and next generation communication systems. Ratnakar holds a master's degree in telecommunication system engineering from IIT Kharagpur. He is a TEDx speaker and has delivered several invited talks and podcasts on technological advances. Sir, it's really great to have you with us. Over to you.
Yeah. Yep. Good morning once again, everyone. So now it's my great pleasure to introduce the next speaker to this audience. So, a very eminent nephrologist, Dr. Dilip Rangarajan, who is the Group Medical Director and Senior Consultant Nephrologist at NU Hospitals, Bangalore. So, he has completed his MBBS and MD from the Madras Medical College. You could see that, I mean, he topped the entrance examination for the entrance into this post-graduation program. And since then, I think he specializes in nephrology. And he is currently the Group Medical Director at NU Hospitals in Bangalore. And he is running a DNV nephrology program as well at NU Hospitals. So his topic today, he will be covering on the digitally enabled healthcare and use of robots in surgery, which is, I think, very, very relevant. I mean, as we move towards, the society 5.0. So increasingly, a lot of sectors, I mean, especially healthcare, is going to be impacted not only by AI and ML, but a lot of robotic advances as well. So it's a great pleasure to have you here today, sir. I really welcome you to take over the stage and address our audience. Thank you very much. Let's welcome with a round of applause.
Before we hear the speech, as a token of our love and appreciation, may I now request Sri Ratnakar Rao to honor our resource person, Dr. Dilip Rangarajan, with a shawl and mohawk. Thank you, sir.
Good morning, everyone, and thank you, sir, for a good introduction. I bring you greetings from NU Hospital, which is a standalone nephrology center in Bangalore. We have branches at Bangalore, 2 branches in Bangalore, one at Shimoga and one at Ambur, Tamil Nadu. We also run the Nephroviro Center at Maldives, the government Maldives Hospital, Indira Gandhi Hospital in Maldives. Now, we had a fantastic teacher in cardiology during our student days. He was KP Mishra, who is a cardiologist, was working at Apollo. Basically, it's from Odisha. He had typical Orient accent. So he used to teach us ECGs in the common forum. So there's something called abnormal beats called ventricular ectopics, which will stand out like a sore thumb. He used to stand out like a sore thumb. So it looks like as if I'm standing out as a sore thumb among a group of engineers and engineering one. But I justify why I am here and show you that we are also digitizing a lot in our hospitals and for delivering healthcare. So I will not be really a sore thumb, but probably relative sore thumb compared to the engineers who are on stage here. I want to speak to you on digital health and use of robotics and medicine and surgery. Now, digital health has really, I would say, revolutionized healthcare. There are a lot of things which we didn't assume and presume earlier that we could do, we're able to do now with a lot of digitization. And the comfort that you have in this handling this digital thing is something to be seen to be believed. It's brought in a lot of safety, especially a lot of safety devices. I'll show you some what we're using in our hospital. A lot of safety factors for the patient as well as for data, which is very, very important in a hospital setting. Connectivity that this stage is brought in is something remarkable. I'll show you the telemedicine how we are well connected now compared to where we were some years back. Now, examples of digital health are the Arogya Setu app, which became very popular during the 2 years of raising COVID. And we proposed ABDM, the Ayushman Bharat Digital Mission of the Prime Minister, where the digital health of every citizen is going to be integrated into a common electronic record. So let us say today I go to Apollo Hospital for something, and tomorrow I go to some other hospital. The entire record of yours is digitized, and it is transmissible from one hospital to another. So the other hospital need not go through the entire history. All your history will be digitized, and you will have it will be very, very easy for you. The patient also need not carry heavy records from one hospital to another, because the first one contains all the data about it. You just have to update the new next hospital about the newer development and not the previous one. So this is in process, and very shortly it will be, there are some training sessions which are going on how to use them for the doctor's point of view, from hospital point of view, etc. Once it introduced, it really revolutionized healthcare, because the data will be available for everyone. Of course, privacy will be there, but the data can be easily shared across hospitals rather than wasting time going through the records all over again. If you are a doctor, you will know that a new appointment patient comes, they come and throw a set of 10 files on the table. Start from 1998 onwards till 2022. It's very difficult to resolve it, not in orderly fashion. 2021 will be in front, and 1999 will be next, then will be 2010, then will be 2012. So by the time you arrange and see all these things, half an hour will go off for this arranging this. So we have employed some physician assistants to put all this in order from the date onwards, so that we can easily go through patient record. So all these things will be made easy if this new one is implemented, because all data will be available for everyone at the tap of a button. Now, I'm not going to talk about bigger things like what you had, like AI and big data, and all, which are being increasingly implemented in the healthcare sector. I will talk about common things where we have used technology in healthcare in our hospital, which has made the life simpler and safer also for patients. Telemedicine, let us go through the list and then I'll deal with it one by one. Then electronic records, that is online case sheets of the OPD cases. Digital images, and summary dictation, that is either your discharge summary or death summary or any referral doctor summary to be dictated, or any letter that the patient wants. Patient safety devices is very, very important. Our IT sector and of course our HR. Now coming to telemedicine, in fact, everyone including me was very, very reluctant to use telemedicine till a couple of years back. Because one, it doesn't give you the connect with the patient directly. Two is that you cannot examine the patient and get the physical features from that. You can only see someone, the image, when you cannot examine, get a lot of data. Like for me, the physical examination is very, very important. I need to feel the pulse, I need to record the pressure myself, and I need to examine all systems like cardiovascular, respiratory, abdomen, central nervous system. All these are not possible. Of course, there are telemedicine where there is a doctor sitting across there, the specialist is on this side, physician with the patient is on the other side, and he can examine and tell you what exactly the patient is having, but still it's not like you examining yourself and getting the data. So we are old 1970s and 80s batches. So we used to examining patients rather than ordering tests straight away. So that connect is not there. It's very difficult for us to accept telemedicine initially. But then the thing called COVID came 2 years back, and then all places were empty, including hospitals. So the only way in which you could connect to patients was through telemedicine. And of course, telepharmacy also. Patients are scared to come to the hospital, to the pharmacy, etc. So then the telepharmacy also started, where patients started ordering medicines to the pharmacy, and the drugs were delivered to patients' door through ambulances. So there was a lot of reluctance, as I told you initially, even for me. And then when the COVID came in, the teleconsults were actually became a necessity rather than an option. What I found was earlier patients from different, like for example, remote part of West Bengal or remote part of Bihar, all of them could have an access to consultation, and it made life simpler for them. No need to travel all the way across to Bangalore for an opinion, and made life easier for a lot of people. The challenge is Wi-Fi network. So as you keep doing the consult, sometimes what happens is on the patient side, the thing gets cut off. And then it becomes very difficult for you to continue. Then you have to resort to the good old audio, make a telephone call for the patient and get the history, and then give advice over the phone. So unless the Wi-Fi is uniform throughout, and sometimes there is a problem in the hospital also when some Wi-Fi connection to some rooms don't happen, then the telemedicine becomes very, very difficult to do. And government has brought in during this COVID thing both regulations for telemedicine, how far the prescriptions have to be made. All of them are very, very clear in the government regulations. So it's good that in a way, one of the advantages of COVID was telemedicine really boomed, and some regulations were brought in for telemedicine from the government point of view. So coming to the electronic records, a lot of hospitals have gone completely electronic, OP and IP. We have started as the last 1.5 years for outpatients, and inpatient by April we are planning to make the records completely electronic. The advantages of that are that all my patients, for example, a transplant patient who was transplanted in 2002, the 20 years of data is still coming to me for follow-up. The 20 years of data files are so thick, so it's very, very difficult to browse through the whole thing, number one. Number two, storage in the MRD. Because a major problem, you have thick files like that, and you have to find a place for storage of these files. All these have been made much simpler now with electronic files, and they just have to store it in the cloud now. There's no need for us to maintain all the records in a big room, MRD room, and then we'll have to keep it in a lock and key, all the security aspect of all these things were a problem. Now with this stage, what happens is that the OPD files are much more simpler to maintain. And for example, the patient comes to me in nephrology, and then he has to go to the next room, to the urologist or andrologist for consultation. Then it becomes very easy. Click of a button is able to see. You need not keep transferring the files from one room to another, one room to another. All of them are visible for all of them on their desktop. So it makes life much more simpler for the doctors and for the patients as well. We are trying to implement it in the inpatient. A lot of challenges in inpatient. The OPD patient comes to me, and then it's very easy. It's just one point. I have to examine the patient, put my notes and put my orders, and write a prescription. That's the end of it. In IV, there are a lot of dynamics involved. The inpatient, we see the patient, write the orders. Then the drug administration nurses have to write their notes. They have to, once I write, let's say, for example, tablet paracetamol at 4 p.m. Now, we write the order for 4 p.m. paracetamol. The sister has to document telling that 4 p.m. paracetamol has been given. So it's a lot of dynamic. Physiotherapist comes and sees the patient. Dietitian comes and sees the patient. Let us say cardiologist comes and sees the patient. There's a lot of dynamics involved in inpatient. It's not that easy to just make it electronic and go electronic straight away. So we have to add a lot of dynamics to it and stat order. Sometimes they come and say, okay, patient is looking right. Let me give him 500 ml of IV fluid. So I write a stat order. So we have to make provision for writing stat orders apart from regular drug orders. So there's a lot of challenges involved in IT. We are slowly getting, and each hospital has to customize it to their case sheet. Now you can't have a general format and say, the same as for cardiology, same for nephrology, same for neurology, you cannot have it. It has to be customized for individual hospitals and the department. This is just a, how we have devised an OPD file. And you can see that you see how the notes here. On top we have the diagnosis, we have the history, and we have the investigation done in our hospital, investigation is done outside also. Record nursing notes. That is, as soon as the patient comes in, the nurse records blood pressure, height, etc. So those things are there in the separate. So we have to give provision for that for the nurses to enter those records separately. Of course, these are accessible to us. The doctor's notes may not be accessible to the nurse, but nurse's notes will be accessible to the doctors. So, I mean, anyone can't go and keep changing their. Suppose I write something, someone can't just come in and overwrite my notes and write something else. So, you have to give access only to certain people for certain things. So, all these things have to be taken care of in the device in the electronic record. There's a place for prescription as well. We have gone digital long back in X-rays, for nearly 10 years. So there's no more X-rays given to in hand to the patients in the hospital. Everything is in HPACs and digitized. So once the X-ray is taken, it's loaded into the system. And advantage is that you do not carry the X-ray from one room to other. All doctors in the thing can view the X-ray at one particular portal. If they go and log in and put in the patient's PRN number, they will be able to see the X-ray in all the rooms wherever you are. System is there in the hospital. The other thing is, I want an opinion from a cardiologist or anyone else. It's easily transmissible by WhatsApp to them. So they just see before they come in itself, they know what the X-ray of the patient is looking like. Suppose it's an abdominal pain, you're taking the X-ray abdomen to the patient. The surgeon has to see. Even when the surgeon is traveling in his car, the driver on, of course, he can view the images and come to the hospital and be ready to see if he really knows what is happening to the patient before he comes in. All these are really advantages of digital. A place for the patient where you get the clarity of the X-ray as good as having an X-ray film in hand. Nearly about 18 years back, we switched to summary dictation, dictaphone, which made life easy for everyone. So earlier we used to have a dictaphone and dictate. Now it's incorporated into all our phones. I just have to dial a number and start dictating. It goes to the section where they have to type the summary. So none of the summaries are handwritten. You know, doctors' handwriting is horrible, except very few. So you can't read anything. So I write a summary. Earlier days, you used to see summaries from everywhere. You used to spend half an hour trying to decipher what is written in the summary. Now life is simpler. We just dictate it over the phone, and they make the summary or letter, whatever, and then put it in your common folder. So I just have to access it from my desktop, correct the summary and put it back into the folder so that the printout is taken. If it takes over in half an hour, I just dictate and then the correction comes within 15 minutes to me, and then I make the corrections and the final result is taken. Printout is taken. Life much more simpler now with a lot of insurance. The summary takes a long time, the insurance process takes a long time. Life is made simpler with the sort of dictaphones where you can make the summary fast. I'd like to spend some time here on patient safety. We are one of the very few hospitals in the country where the entire hospital is connected with Massimo safety device. Massimo safety device is Massimo is a US company. It is coming with the patient device where it's a simple thing. You just put the probe onto the patient's attached to the device. To the patient's finger, you get it's like a pulse oximeter. You get the pulse oximeter and pulse rate. And if you are in the OT or if you are in the ICU, higher end model of the machines are available where ECG as well as the carbon dioxide, all those things in the OT parameters will come up, whatever is required for them. So what happens is that this is Wi-Fi connected, it's connected entirely through the entire hospital. So every patient room and every patient bed, whether in the ICU or on dialysis or in the OT, connected to this. Let us say first floor patients are there. Every room of every bed of the patient has this device, small monitor there. Yeah, this is the maximum monitor. This is the one, this is the complex one which we use in the ICU. Whereas the ones in the ward will be somewhat smaller than this. So what happens is that the Massimo device is connected to the patient. It starts showing up on the patient room monitor. These are connected centrally to the nursing station. So the nursing station has a bigger monitor where you see that, let us say there are 10 patients in that floor. All the parameters of the patient comes in a small box there, room number 101, 102, 103, 104. So on the base on the nursing desk, the nurse can see all the vital parameters of the patient in one place. So what has happened? We have what's called new scoring, modified early warning score. Where let us say new score 1 will be patients with low risk. New score 4 or 5 is patients with a higher risk for developing complications. So one of the things are all this pulse rate, oxygen saturation, blood pressure, all these things come into the warning score. So sitting at the desk of the nursing table, they can know which patient is going down. Suppose saturation of 95% becomes 89. So they can go pay more attention to the patient. Someone who needs to be shifted to the ICU can be shifted much faster. Some action to be taken can be taken much faster with this Massimo device. So Massimo device is connected. And to add to the safety features, what they have done is they are given 2 pages. One pager for the same floor, let us say nursing station is there and the nursing supervisor of that floor. Once the monitor starts beeping either for a varying heart rate or varying oxygen saturation, what happens is that within 30 or 45 seconds, the beep goes to the first pager to the nursing in charge of the floor telling that action has not been taken. Within 1.5 minutes, the action is not taken. There's a second pager which is kept in the ICU with the doctor or the nurse in charge. The pager goes telling that from the first floor, so and so room, oxygen saturation is dropping. The patient meaning that means they have not attended to the patient. So there's multiple safety. One is it gives a beep in the floor. It goes to the nursing supervisor in that floor. Second one, it goes to the nursing person or the doctor in the ICU also. So that if one fellow sleeps off, the other fellow will be awake and make sure that they call the first floor and find out why the action has not been taken and the beep is going on. Of course, sometimes patient removes it, goes to the toilet, it keeps beeping. So all these things have to be taken care of. So the nurses are supposed to go and check why it is beeping. And if really patient is gone to the toilet, they have to go and mute it at the patient station. They can't mute it centrally because once it's muted, you will not know what's happening. So they've given provision for them, the privilege for them to only mute it at the patient's. When one patient comes back to the toilet or after eating, you have to switch it on. So this device has really done wonders in a lot of hospitals because a lot of early warning scores have been picked up and patients' lives have been saved. And early resuscitation can be started with this device. Not with this device, with the use of this device. And CCTV camera. This we have started about 10 years back. Most of the places CCTV cameras installed more for monitoring theft and who came in, who went out, etc. In our hospital, we use CCTV camera predominantly for patient safety measure. That is hand hygiene. Ours is one hospital where the doctor's hand hygiene is 100% in most of the areas in the hospital, which is a record. Doctors are the worst people who don't wash their hands properly. The nurse follows orders, technician follows orders, staff follows. Doctor thinks it's be all and end all. So and people are scared to tell the doctor go and wash your hands. So hand hygiene monitoring, you started nearly 10 years back with the CCTV camera. And if you don't wash your hand and enter the ICU, your photograph will be done next day in the morning. The infection control nurse will monitor all this in CCTV camera and take a picture and say, Dr. Dilip, this hand wash while entering ICU, it will be throughout the hospital, the image will go for everyone in the hospital to see. Same way for everyone. Even before this, our doctor's complaints was very good because we have built it into the culture. Very difficult to build the thing into the culture. So once you have built it into the culture that hand hygiene is important, then everyone follows. Nurses is around 90%, technicians is around 85 to 90%, housekeeping is around 70 to 80%. So we not only look at doctors and staff, you can get infected from a housekeeping person who shifts you from the bed, from the ICU bed onto the stretcher, then onto a ward or for X-ray. So even the housekeeping, IMS, whoever it is has to wash their hands before touching the patient, wash the hands after touching the patient. In dialysis, for one dialysis session, about 80 times the technician has to do hand wash because patient mission, touch the, before touching the patient, wash, then mission alarm will come. They can't go and touch the mission straight away. They have to wash the hand and touch the mission. All these things are monitored completely directly onto CCTV camera. So I am happy to say that our hospital infection rates are very, very low. Medical people will know what's called MRSA, precision-resistant staphylococcus aureus, is one of the dangerous bugs, as well as what we call belly bug. What's the Klebsiella, which is multi-drug resistant. There's no drug in the world which will act on it except one or two. So most of the super specialty hospitals have a MRSA rates of 40 to 50%. And most of the other things are almost coming to 20-30% now. With all our hand hygiene and our antibiotic protocol, I'm happy to say that our MRSA rates are only 5% after so many years in the hospital. And our other, the Delhi bug, now from a lot of patients coming from other hospitals, Delhi bug is slowly coming up. But our Delhi bugs are extremely low, less than 1% a year back. Now we have patients from a lot of other hospitals coming in, already treated with antibiotics and having a lot of foreign bodies, insect stains, etc. So rates are going up now, but with strict hand hygiene measures and antibiotic protocol, you can control bug resistance as well as infection rates. Here, as I told you, on a daily basis, we get the information from all quarters. In fact, from dialysis, from OT, from wards. What we do is, this is the pattern. We write the location, time, area, doctors, nurses, technicians, housekeeping, etc. Number of opportunities of hand wash. Suppose I go and see a patient, the opportunity of hand wash is 4 times. How many times I have done it? Is it 3 out of 4 or 4 out of 4? So the percentage is calculated based on not the number of patients you see, number of opportunities per patient. So I may first wash my hand and then put the state on the patient. Then again I come back and then I know the pulse of the patient. So the opportunities are 2, not 1. First washing is 1, putting the step. After I put the step and come back, I have to wash my hands and again feel his pulse. So the opportunities are 2. So all these things are looked into in detail. So how many opportunities, how many missed, what the percentage. And then as I told you, photos flash throughout the hospital. You know who are all the fellows and you know who all have to be trained again. Dialysis, new technicians come in, we train them. They don't imbibe the culture. So we know who are all going wrong. It's not a punitive thing, but we are built in that culture. Earlier we used to raise incident reports. Even now, I am one of the strictest person raising incident reports for everything in the hospital. So they're scared when I come around. They don't know what I will catch out them in part. But the point is, the incident reports earlier we used to say staff nurse 1. She used to be thinking that punitive action will be taken against her. Oh, I have not administered drug properly. Now what we have done is we have removed all the names in the incident report. It just says SN001. No one will know who it is. So we are concentrating on the process, not the person. So today this nurse, tomorrow some other nurse is going to do the same mistake. So how do you correct the process rather than the person? That is the idea, and then this culture is built in well, and now it's taken up very, very well in the hospital. Another important thing is we have incorporated critical alert system. That is the lab. We have primed the lab already. We have fed into the machine. What are the critical alerts for various parameters? Say, for example, blood sugar. You would have put in 300 as the higher limit and say 60 as the lower limit. Let us say serum creatinine, which is our field in nephrology. You would have put in say 7 or something as the higher limit. And for each parameter, hemoglobin, you would have put in 16 as the higher limit and let us say 8 as the lower limit. So from the machine, anytime these reports are generated from the machine, automatically the abnormal parameters will go as a message to all the doctors, the consultants. For example, and the location also. We have 3 units in Bangalore. So it tells you when you south, PRN number 111222, hemoglobin 5. So all the doctors will get. So even as outpatient, if you come and go, or inpatient, you are there. At any point of time, the morning or night, I know. Even the night, middle of the night, someone 12 o'clock, some patient comes in, parameters is abnormal. I check the report and then call back to find out if I am called, whether action has been taken, the duty doctors are sleeping or are acting. So such a device where the abnormal lab parameter, message goes to the doctor with all these reports, and then there's a register in the lab. The lab, apart from sending messages, they'll also call the doctor and write down that which doctor has been informed about the abnormal report. The doctor said there is an Excel sheet where they have to maintain, let us say, someone's sugar is 40, this is an outpatient, is someone given blood and gone is 40. Now they are supposed to call the consultant on call, find out what is the problem, call the patient to find out what is the problem, and then give the solution, what it is, and they have to document. The Excel sheet, we are monitoring this like a hawk every week. The Excel sheets, the number of critical alerts that have come are matching with the number of actions taken in the Excel sheet. Every week we match and see whether it is, sometimes the critical alerts will be 10, whereas the entry by doctors will be 7 only. Then we find out who is not entering, why we are not entering, whether action taken and not entered, or action not taken and not entered. All these things are very, very important. It's a big headache for us, but the patient's point of view is absolutely safe. Technology has made it easier for us to monitor all these things. So we have incorporated simple things. It's not a great thing like AI and all those things, but simple things made a major difference in patient care and patient safety. Then our hemodialysis machine. In fact, our Fresenius hemodialysis machine has what's called a TDMS, therapy data monitoring system, where the machines are again connected to a thing. So with TDMS, what happens is that it's connected well, and sitting at home from my laptop or my phone, I know all the parameters of 11 patients who are undergoing dialysis. I can give them instructions as to what is to be changed during dialysis session. Same way, we've got an automated petroleum dialysis machine where we have interactive devices. Patient is doing dialysis at home. These parameters come straight to me, to my phone or to my laptop, and I know what exactly is going wrong or what is going right. Of course, in our IT, we have one of very good technical details I do not know, unfortunately, but we have one of the very good IT systems where the backups are very good. We store it in the cloud, and we have 3 units in Bangalore and 4th one in Ambur. So the backup is done between units. So the south unit is backed up in west unit is backed up in south, and Shimoga is backed up in west and south. So that any loss of data from one place can be retrieved. HR has become totally paperless, and all the training records, all the vaccinations of staff, which is very important. That's also a safety point of view from the workers also. Not only from patient safety, the health worker safety also has to be looked into. So all the data regarding the safety of everyone is kept in the HR file of every person. It's become paperless now. And all our finances also. What is this one, that is the salary, what is the deduction, everything can be viewed in one thing. And we document a lot of things. Memos being served to people for wrongdoings, and of course, positives and negatives are all documented in each and every one individual file from housekeeping to the top consultant. So anything, suppose there has been a complaint against the consultant regarding anything, all those things will go into that file. And everything is documented, not a single thing is left undocumented. Disadvantage of digital legal. A lot of consent forms are not still very clear whether we have to take the patient's signature or digital signature is okay. A lot of still we are taking consent forms with the paper, and then we are loading it into the system. Of course, privacy, we all know, cyber security, the problem we had with AIMS now. So struggling a lot. The big problem with digitalization is once I started seeing patients, if there's a problem with the internet and it's down, everything from the front office to the OT, there's a stop to everything because you can't register, you can't generate reports in the lab, you can't enter records in the thing. So still some amount of manual thing has to be a backup for this digital system. Access to internet, of course, elderly people, very difficult for them to say, go to this app, go to that app, they will not be able to do it as well as an younger person. And patient connect. Now patients are starting asking, doctor, I'm talking to you, you're sitting and typing. So they want you to just listening to them. So one period after I tell them, boss, I'm typing only what you are telling. I'm not typing anything else. So the connect is not there because there's more entering all the data. This is our latest CMS license system of Robo. Robo is fast. I'm not a surgeon, but it's all math derived from net and from my colleagues. So almost all these fields, robotic surgeries have been introduced. Now, general urology, oncology, we have a lot of surgeries being done in urology now. Effective removal of kidney, bladder repair, a lot of children undergoing surgeries where the ureter is to be connected to the bladder. These surgeries, a lot of prostatectomies, all these things are now being done using robo. The advantages are shorter hospitalization, reduced pain and discomfort, skill. In fact, it can go through very difficult areas and suture where you cannot do it manually. Where you have to struggle to do manually, it has a nice maneuverability of going in and taking sutures, bites, everything. Smaller incisions resulting in lesser infection, lesser scars in the body, reduce blood loss and transfusion, minimal scarring. Point is, unfortunately, there was a report from UK where a half-trained fellow was dependent on 2 more people for handling this. Those 2 people who were supposed to be helping him went out for coffee. The patient died on the table because the robot went and cut the whole thing. So, and that was debarred from practice for about 10 years, something like that. But of course, now he's back, but not into that, but in a different field. Unless there's also a human element, unless you know how to do it and you're skilled, trained, and then apply your mind. Advantage here is robot, you can sit in the room and do. There's no need to stand and do prolonged surgery. You can sit and maneuver it very, very well, very, very comfortable. The disadvantage here is costly. So approximately around 2.5 times more costly than regular. So suppose some surgery costs 1 lakh. Laparoscopy costs 1.5 lakhs. Robotic surgery costs 2.5 lakhs because the investment in robots is very heavy. Goes in crores. So the cost has to be recuperated, and so all the surgeries are very expensive. As I told you, complication surgery. There is it's a master slave. That's what the master orders it to do. The master is sleeping and the slave does what he wants. It occupies a lot of space. The earlier days, when the hemodialysis started, when dialysis was there, one machine used to be the size of the room. Now it's all very compact and one slim machine which is there. So hopefully, robotics will become like that over a period of time. Other thing people are scared is unemployment. Probably they replace a lot of doctors. And for example, MRD. Now most of the records are electronic, and if you have a robot there sitting and filing everything, there is no need for MRD. Similar way in pharmacy also, a lot of robots are distributing drugs, storing, inventory, everything is done by a robot. So whether it will lead to large scale unemployment over a period of time is cause of concern. Thank you very much for your patience. Happy to answer any questions if you have.
Thank you, sir. As a token of our gratitude, may I now request Sri Ratnakar Rao to honor our resource person, Dr. Dilip Nagarajan, with a certificate and a memento. Thank you, sir.
So thank you very much for giving a peek into your world. Very interesting.
one question may be like, I could see that across your 4 hospitals, you are actually accumulating a lot of very, very valuable data actually. So, are you planning to harness this further using some analytics techniques or something to improve the clinical outcome? In fact, not only from the clinical outcomes, from the patient convenience point of view. Now we have wealth of data and how long is the patient waiting time in the OPD. So, when the patient registers, when the patient sees the doctor. So, all those things we are monitoring, and also our NABH warrants monitoring all these parameters. Earlier, it all used to be manual. Now we have wealth of data on all this, and I didn't want to make a lot of shortage of time. A lot of things which we are doing, for example, we have to do a lot of about 40-50 CQS quality indicators for NABH. All these things we have made a Excel sheet, and most of them digitized directly. So they just have to enter the data and the calculation comes on straight away. So all these things are been digitized, and we have a wealth of data regarding anything that you want. For example, for MRD coding, ICD coding is excellent. So we can, let us say I want to know how many fellows had, how many of the patients had prostate enlargement and had surgery, how many of them had drug-induced kidney problem, how many of them had stone-induced kidney problem. At a click of a button, I can get all the data. This made life simpler. Now all my discharge summaries are now easy. I need not go fish around. There's a discharge summary column in the system. So once I don't keep the year, I keep putting the patient PR number, I get the discharge summary so easily. So these are the advantages of this one. We have wealth of data across all the units. Definitely, we have ideas of overall improvement, not only clinical outcomes, but also the administrative part, a lot of improvements being made.
First year students can go back to your class. Please go back to your classes.
Yeah. So, ladies and gentlemen, it's a privilege to introduce you the next speaker. We have Sri Srinivasa Rao V, who is the chairman and MD of PT and BT. So he comes with a wealth of experience. I mean, he had an industrial experience of about 26 years, out of which 19 years he spent in the corporate world,
working with your TCS, Infosys, iGate, Satyam Tech Mahindra, helping them transform digital transformation in about 19 business units and 20 practice and delivery units. So essentially, he is now acting as a chief digital transformation consultant, transforming the businesses across the sectors. So he will be speaking on align or exit in the era of the fourth industrial revolution, transitioning from traditional to digital innovations. Sir, hearty welcome to you.
Before we hear from him, may I now request Session Chairman Sri Ratnakar Rao to honor our resource person with a short commentary.
Good morning. What is Society 5.0? Any idea? Because the conference actually thought any idea. What is that conference? Engineer and speaker for Society 5.0. Unless I understand what how it is. Very important for us to understand as an engineer. So engineers are like Brahmas, right? They are creators. If you want to create a better future, you should understand what is that future looks like today. Then you can start the foundation building blocks today. I think the conference whole objective is to understand what is and then start working on designing what are the systems required for having a better future for that 5.0. Do you think when the 5.0 will happen? Yeah, maybe 2040, 2050. So we are still in Society 4.0 is going. Of course, Japan is talking about 5.0. That's fine. But actually, all over the world, I think we are in Society 4.0. We are in a society but in a different configuration, a different attributes. I mean, society is nothing but I think connecting with people, connecting with nature. But the way you interact with nature got changed. The way you interact with people got changed. The way you interact with systems got changed. But still, we are a society. We call 4.0 like a software guys. We are doing workshops for everything, right? So we are very good at giving workshops. So why not we give a workshop for society also? Just let us do society 4.0, industry 4.0, or all those things. So I would like to share a few of my thoughts on what is society 4.0, 5.0. First thing, how many people agree that we are giving light to things? What are the things are there in the world? Shade is a thing, call is a thing, tree is a thing. What are those? Can I give light to a thing? What is light? As a human being, I have to breathe otherwise I will die, right? So, but a thing doesn't need to breathe. It can sense, right? There are so many sensors, right? You can think. There is an embedded software and processors are there, right? That think, right? And then you can communicate. There are generation, telecommunication, food generation, telecommunication, and then if you want a short range, there and all. You can also predict, right? Everybody talking about data is there. I have artificial intelligence, machine learning and all. Don't you think today a car is able to drive itself? Autonomous cars are there, right? That means I am giving life to car. It is able to think itself, it is able to drive itself, it is able to apply the brakes. So that means it is able to sense, think, communicate, predict. Oh, if I go on probably this, I may go on. It is able to predict and control. I think that is the society we are going to live. We assume that Indian population by 2050 will be divided to 300 to 400 crore. Indian population. What is Indian population? 140 crore. I am telling by 2050 it will be 300 to 400 crore. Is it possible? Huh? Possible. You see on the road robots have the light. You see on the road cars which have the light. You see a washing machine in your home which has the light, right? All those whatever things have it. The light means, I mean, there is no surprise, right? Sophia, the robot got an identification number in Sophia, right? A robot got an identification number like Aadhaar what we have. So we expect all these living things, non-living things we have with an Aadhaar. Maybe I'll give an Aadhaar for my car. It also has light. I think that is a society what we are going to do. So let me just give an idea of my thoughts on what is society. So we give life to things, agree? Yes or no? Can I give life to a chair? How? The car is sitting there, then the chair will say that you are sitting like this. Okay, the sensors are saying that you are not properly sitting. So, and it is also thinking and telling that you have to sit right. It is giving some sort of a communication. It is predicting that if you sit like that, another 1 hour, you will get a back pain. And you design that type of machine for this institution. Okay, so you are giving life. And if you are going to work, these things are very simple. Your boss may not be a human being tomorrow. Right? So your colleague is not able to give it today in China and other places. Your colleague is not able to be a robot, but you have to work together. And there are some new roles also getting created. The robot supporting manager and all. That means I have to collaboratively work with these robots and myself as together. This is called society 4.0 or 5.0. Right? Then people communication and collaboration reach to next level. Somebody sitting at America, how I communicate today? You have WhatsApp, you have some what video conferencing, Zoom, and also started, of course, it is not affordable. Holograms are. I am here, and the US they come and stand here in the hologram TV. As if we both are in front of each other, that is the communication we are going to see in Society 5.0. Even the person is thousands of kilometers away, as if the person has come and stand here and we both have a conversation. Imagine the society in the next level. Another important challenge what I could see is how many people use social media here? Everybody. What is the change? I think our generation and your generation, what is the change in the human relationship? By using social media, do you see any change in the human relationship? Do you see how people communicate each other? Did you observe any change? Anybody? Right? Okay, that's positive. So much of it's like other interaction. Without even seeing the face, you say he is my close friend. Somewhere sitting in in a car. Right? That is okay. But of course, people also got addicted. There are side effects also. You don't get more likes and get depressed. So my photograph in the morning, I put it so if somebody is not seeing it, I get depressed. If I probably put a communication and nobody is responding to me. So there are so many side effects also. You got addicted of social media. Right? That is okay to some extent. But imagine now how many people heard about metaverse. Right? Now what you are going to do is create your own imaginative world with VR headset, virtual reality headset, and you get into that imaginative world, and you want to murder somebody, you murder somebody. You want to use the drug, you will use the drug. That is negative. You want to learn, if you want to go to Mars, I don't need Elon Musk to give that. It is $1 million to go to Mars, right? If I just wear a VR headset, a virtual reality headset, I'll get into the Mars, I can rotate the Mars with my hand, and I can see how the Mars is there. That means you are basically of both bodies are non-existent world imaginative world, for example, I want to find something, then I create my avatar. And I want to be a star, right? So I will get into that imaginative world and I'll pay 200. Okay, that is the world what we create, and we have to see that is called society 5.0, where coexistence of imaginative world and real world. I don't think still you are in the imaginative world. You are still, I think, outside only. You are using social media, still outside. But now when the virtual reality, augmented reality, all these metaverse comes in picture, when you wear this, I'm worried now. How many people see mobile phone when you take it to people? Tomorrow, imagine everybody is very real. What they do, like this. How many things we are, you know, when you are right? As if you think that I think 1991 when I was first time went to London, I'm very honest, I did not know that there is something called airport. To be honest. So I was in the railway station and somebody was talking to himself. Who is talking, right? There was no voice from other people because he couldn't speak this one, right? Now imagine wants to wear a headset, VR headset, and then 4 people sitting in the family, everybody is busy in their own imaginative world. What they do the action, like birds see videos, how the people will press the hands in this VR headset. I just imagine. Okay, so all these things now. Okay, the last point I would like to tell here is there is no object exists in society 5.0 being your human body. Including human body, every object in the nature to the extent possible. Okay. So every object we have a software will be there in the brain, a software will be there in the hand. So I think that is the world what we are doing. You understand what is society 5.0 now? Clear? Very interesting and very alarming. So unless you understand, it's only this is deep from what is said, but we had as something has to be right. Utilize. This is called society 5.0. If I want to ready for this society 5.0, these are all the policies I have to define. These are all the engineering systems I have to define. These are all the new skills I have to define. After all these things to be done. We cannot go like in a society 3.4.4. Maybe I think British came 1,000 years they rule and we are still slaves. All those things doesn't work. We have to prepare now. Okay, this is what in summary. Japan very, I think, intelligently put it. Even when we were, I think, the coexistence with nature, with animals, probably I think the first generation of the human beings, they thought society 1.0. Okay. So from there, we got into agriculture economy, where agriculture has become a very prominent in our life, probably in 1700 and all. So that is society 2.0, and the agriculture was the driving force to earn the money, to have the new job opportunities, lifestyle and everything. Agriculture dominated, that is society 2.0. The society 3.0, then it started all these machines, the production, plants and everything came. That's where I think we started spoiling the environment and all this, right? The seed for that spoiling the environment started in the society, industry society. Then we all came, 95, I started, for example, my career, then we talked about information society. All those, I think, the services and whether it is IT, healthcare, banking, there is a lot of knowledge and information has driven the society. Now, whatever I told, society 5.0 definition, that is just going to drive it. I think this is the way the society got evolved. So, in my view, unfortunately, society 3.0 and 4.0 in India, we have done it okay. I don't think with a great vision or a strategy or a blueprint. Has happened, but the time has come for us to design a blueprint for the society 5.0. So, a few examples I want to share with you. What is happening? Whether we call now, let us take 4.0 to 5.0. Maybe in the 10-15 years we might do that. So look at here, few examples. In current society, what is happening? I said the technology is going to become a driving force. Look at that is a T-shirt, right? The T-shirt has what? Sensors, electrodes, and it will read my heartbeat automatically, and all the data will be sent to the doctor or family member to whatever the communication files you are. And if any alarming situation is there, the doctor can immediately tell the patient you have to take it, or the family member may rush the patient to the hospital, right? Don't you think it is the innovation which is coming out with the technological innovations and engineering innovation? Yes or no? Right? So this is what the thought process is required now. Even a T-shirt, you are injecting software. I said there is nothing exists going forward without software. Now I have shown only T-shirt, right? Next one. Look at here, the diabetes has become a very, very, very serious issue in India and all over the world. So you have to take the insulin at the right time. If you don't take it, then probably you get serious issues, right? Now this is a solution. I'm sure you might know you are from healthcare. Okay. So some of the companies have developed something like, look at there is a glucose sensor. The body, they put it here, then what is the glucose level it will read? It will send that information to the insulin pump, which is also attached to the body. Then it will pump the required insulin into your body through a nozzle and injection. It is automatic. You don't need to worry about it. Right? This is the innovation. What is happening today? Don't you think it is again a technology? It is sensing, there is a communication, right? There is electronics here. So this is another classic example of how in the society the solutions or products are emerging. This is a factory. I mean, you see now manufacturing factories and all. I think one of the companies in China, they have 90% of the people removed from the top. 100 people are there, 90% they remove, and only 10 people are working. That means the robots and the people are working together. Okay, look at here one classic example. This is a bottling company. So everything is automated. There is a machine one. In front of that machine, you got the bottle through conveyor. The bottle has the RFID code, right? Then the machine reads that, it knows what is that fuel I have to fill. Automatically, you don't have any human being. Then it completes, then the instruction is move to the next machine. Then the next machine will put that spout or something. Then the instruction is read and then it moves to the third machine, then it is labeling. Then fourth, I think the third machine will send it onto the conveyor, it may go to the whatever place it is, right? So this is what the shop floors of the future. This is only a shop floor. But don't you think even a retail store is changing? How many people heard about the AR glasses? Or if you stand in front of a mirror, okay, you don't need to go to the dress changing room. My body is there. I can just simply touch the attire, a T-shirt, and it will come and just show me exactly as if I was in a mirror wearing that particular attire. Today, such type of workplaces are emerging, right? So the workplace here is a shop floor, but in some other industries, maybe a retail store, in some other industries, it's just office. In academic institutions, the workplace is a classroom or a conference. There also the technology is getting there. Then this is another interesting thing. This is a bed. How many people fight at home? I want to have a fan. I don't want to have a fan. Brother, sister, brother, okay, wife and husband. Agree or not? Right? Or this side it is well. So this bed is designed. Okay, left side I can have a one level of temperature. Right side I can have another level of temperature. Because I want a very cold weather. Left side I will sleep. On the bed itself, there are sensors, again, embedded software and all. And also, when I'm sleeping on the bed, it will read what is my sleeping pattern, whether I slept properly or not. What is my health indicators? In the morning, probably my mobile phone, it will send all the information, right? So the bed sheets are becoming intelligent. They are software defined. You inject every software into the bed sheet also, right? Okay. Very alarming situations if you have to work in a very dangerous site. Okay, then the suits are becoming again intelligent. You have sensors and you have the light, right? And which location you are. If you are in a very dangerous location, automatically it is connected in the mobile phone. It is giving the alarm to the management or the supervisor. This guy is getting into the dangerous zone, right? Or if you are getting into the dangerous zone, the suit itself will tell you, hey, stop there. You are getting into a dangerous zone, right? The suits are becoming intelligent because I am giving light to the suit. Okay, another interesting thing here, but I'm giving examples so that you can understand what is the society 5.0 or 4.0 in our life, day-to-day life. You see there. So the bank has done a very interesting job. What is the exercise you are doing every day? Based on that, I will give you interest. I'm very poor. I get 0% interest. I don't do physical exercise. So if you do a great exercise, if you are walking probably the number of steps 10,000 per day, I will give you more interest. How they track it? Probably you have some Fitbit type of a thing. So the data is read and then it is sent to the banking system. then the bank system will see that and say that, okay, your interest is this month, it is good. Next month, it is not good, right? So don't you think now banks are using even technology to ensure to encourage your health so that you also get the more interest. So your health is their concern as if they are creating that. So this is the next one. So we don't need to go to a bank now. I can directly get it into metaverse. An imaginative world, as if I am talking to a representative of JP Morgan Chase customer representative because I am wearing a VR headset. Actually, I wrote one article. I want to get into Hastinapur. When there was Duryodhan, Dharma, Sri Krishna. I'm a very big fan of senior ATR. I'm sure people know about ATR in Andhra. Okay, I'm not this age here, senior. Okay. So I just wrote an article. I wear a VR headset at my home, my office, home office. And automatically I got into Hastinapur because VR headset is there, right? There ATR is there and Duryodhan or Krishna, Dharma, Sri Krishna and all. Then I have a discussion as if I'm a close friend of Duryodhan. So I requested him please stop the work. All imagination, right? It's an imaginative world I created. Then nothing to be sir, what a great idea you have. What idea you I don't know. Okay. Then we stopped. Then we both went for a topic in metaverse. Then with NFTs I purchased with blockchain enabled. And then Duryodhan gave something like a gift to me. Then I took it, I removed my VR headset, and I am at my home. You got my point what I'm saying? These are all imaginative worlds we are going to create. Okay, any questions till now? So you are getting a feel of what is society, how you are going to live, how you are going to coexist with the non-living things which are giving life, right? Tomorrow a plant can have basically life. If you saying the moisture is low, please come and pour the water. People are putting in the soil the sensors, right? If the plant doesn't have the required water, then you can send a message, the water is not coming, please come and save it. So with that note, I think there are so many of course. Okay, this I don't know when the sound will come. This is the robo. Okay, yeah. Sound is not there. Okay. This is the, I think, robotic swarm where this will lay the tiles. You don't need any human being. Will lay the tiles. And the previous guy, go now. The next one, another interesting thing. The guy, you take the tile, tiles are there. Taking that. Students are all very slow and they take maybe another 5 years. Some more intelligent, they can do near to the section or more than that. So we think now these guys will take over the playing one. You don't need labor. These are all the changes. Okay, so in summary, so as I said, every object has the software. There is no object will exist in future without software. Pacemaker has 80,000 lines of software, right? And look at here, the Joint Strike Fighter F-35 has 60 lakhs lines of software. And there is a car which has 1 crore lines of software. Without software, if anybody says that software is not required, irrespective of the whatever profession you are in, it doesn't matter. You have to deal with software whether as a user or whether as an innovator. So this is okay. Now, just to summarize, what is the key message I want to give from all these examples is very important. So another example, look at here. This is what? There is a smart pole, right? Most of the cities now using it. What are the things are there in the smart pole? On the top, there is a solar panel, light, boards, surveillance cameras. Then you got the bottom, there is a speaker. Maybe a municipal corporation can announce that anywhere as the municipal corporation from central location they can announce the announcement, not like only standing at one place. And there is a plug for charging your bike or car. And at the bottom you have sensors. If any floods or rain comes, then you know that what is the water level on the road because the phone has the water, right? Okay. So what is the message here I would like to give you today? Do you think this smartphone can be designed or manufactured with one engineering discipline? Is it possible? You need what? You need civil engineering, you need mechanical engineering, you need electronics and communication, you need computer science, you need software engineering, of course, it could be instrumentation, calibration, sensor. Okay, that is very, very important point. How the engineers today, if they want to prepare for the future, they should understand that it's not by engineering only. I should also understand the dependencies on other engineering disciplines if I want to prepare for it. The second important point is the engineers also need to understand it is not just engineering, the technologies and softwares are playing a very vital role. If you see any of the examples I have shown without technology and software, any object or any product or example existed, right? Yes or no? Not there, right? So you also need to understand as an engineer, my God, it's not only just I am a mechanical engineer, just I know mechanical engineering. I also need to understand at least the breadth of other engineering disciplines so that I can design a right product or I can involve others, electronics engineers and communication engineering. At least I can communicate. It's not like a Greek and Latin. You talk something I don't understand. Okay. And also I need to understand what are the technological influences on engineering product. Right? Here, there are two classic examples. So look at here. So the key message I am trying to give here is if you are an engineer, you need to understand it is my engineering discipline, whether mechanical or civil. I have to understand other engineering disciplines, their dependency, and what is the correlation, and all also with the technological things like AI, ML, robotics, blockchain, right? VR, AR, and all. So with that, many organizations fail to respond to these stages, right? I mean, you saw that. One classic example I will tell you. How many people know that a baby diaper is very intelligent today? The baby diapers have sensors, embedded software. So what is the temperature of the baby? Something. What is the blood pressure? Okay, and what is the wetness of the diaper? All the sensors are there. And there is a small chip which reads the data and send it to 5G to mobile phone. Mom is sitting at office. In the mobile phone, mom can see what is the health indicator of my baby. Right? So suppose if you have a company in Chennai, they have been manufacturing wonderful baby diapers for the last 30 years and they are the masters and leaders. Imagine somebody from this institution come up with a new company called a smart diaper and they have, in addition to those characteristics, what this small company is doing, they also bring the sensors and chip and then connecting to the mobile phone, who will exist in future. Right? So if organizations, irrespective of size, if they don't understand how my products will be, how my customers will be, how my services will be, what new systems I have to engineer, what new products I have to engineer, what are all the new skills I have to acquire, then there is a great chance that they will not exist. What happened to BlackBerry? What happened to Nokia? Few examples, right? It's not like they don't know. They follow what changes are happening. It's not like they don't have leadership, but most of the times it is resistance. Most of the times it is organizational barriers that will make them low flexible and low resilient. So with that, what I thought, this is my sharing. I've been working with Professor Sivaprasad Garu, Subbarao Garu and all. Yesterday also we spoke with Dr. Ramesh Garu, AMPDC. I think there is a need for all these engineers who have to be prepared for Society 4.0 or 5.0. I think we should start talking about, I have to be a digital mechanical engineer, I have to be a digital civil engineer, I have to be a digital material science engineer and all. Don't say that I am a mechanical engineer, right? You understand the context why I am saying you as a digital engineer, you should know the convergence of multiple engineering disciplines and also the effect of the technologies in the training engineering. If you don't get such type of a thought process, your products, what you design are irrelevant. Like a baby diaper example. If I want to get a baby diaper which is smart, if you don't understand this context of digital engineering, you will not suffer. And you are not useful for me as an industry, or if you want to start your own company also, you can't come up with very great products. Yes or no? Right. So what is that digital engineering? Look at here. I defined, I think it's covering. Okay, look at here in the circle here. This is something I call it as a digital engineering innovation skill wheel. Okay, what I said, you will have engineering convergence skills, agree? If I am manufacturing a car, so there is a breadth I should know. There is some component of electronics, component of computer science, component of instrumentation and all. So there is something engineering convergence, breadth of that people should know. My core could be anything, could be civil, could be mechanical, it doesn't matter. This plus the other engineering disciplines. And I also talk about technology convergence, right? Without technological convergence, the engineers cannot engineer a new future, right? New products like artificial intelligence, machine learning, blockchain, AR, VR, and all. That means multiple technologies you have to understand, and the impact of those technologies on your products needs to be understood. Right? That is the second part. And the third part, if you want to be an innovator, in fact, Dr. Ramesh Garu and the team started at IIT Madras how to create as many hundreds and thousands of innovators from India. Why you need to import the products and why you need to import the machines from Western world? Why you want to depend on only these guys? Why not? We build made in India products and made in India systems, right? That means you need to have an extraordinary thinking and innovation skills. So IIT, the government of India, starting an initiative called System Thinkers are required for this country. If you as an engineer, if you are not a system thinker, that means a holistic thinker, you will never innovate. You can have just a product, somebody did it in US and I copy it. Flipkart copied from where? Ola copied from where? Oyo copied from where? Airbnb. So let us not copy. Let us create something. If you want to create, if you have to be a Brahma, you should be a system thinker. Understand what I'm saying? So the thinking is very important for an engineer. So I talk about engineering, the convergence, I talk about technological convergence, I talk about the thinking convergence. Thinking also, there are so many thinkings are there. We can do that system thinking. Under that, there are, your brain has to be prepared for different type of things for different situations, right? Next is domain. Okay, if you are in a, for example, automotive industry, you should have some knowledge about that, right? You cannot design a product without knowing the domain, right? Or if you are in the chemical manufacturing industry, you should know a little bit about the chemical manufacturing, right? If you are probably in the Samsung, for example, there are the electronic manufacturing or consumer goods products, right? So you need to understand a little bit about it. And finally, if you are not able to manage these products and projects during execution, okay, you started. Somebody gave the funding. Okay, you have a great idea. You design the solution. Okay, but you don't know how to execute it with the teams. You don't know how to work with teams. You don't know how to collaborate with other companies. And you don't know how to make the plan a reality. You don't know how to identify the risks. You don't know how to manage the risks and all. I'm sorry, you are paid, right? As an engineer, you also need to understand. So this is what I think when you see here, okay, the top one I'm saying, all these things, I call it as a breadth. But this is the core, right? One example. Mechanical engineering, of course, I did my mechanical engineering, probably that's why I'm telling here. So you see here mechanical engineering, what I said, this mechanical engineer today needs to have a preliminary understanding, not the depth. right? A preliminary understanding. Not in the first year, it's my view, it should probably spread across 4 years. The other engineering disciplines knowledge also needs to be spread across 4 years and say that I am a mechanical engineer, but I also understand how this mechanical engineering talk to electronics, talk to instrumentation and all. Okay, that is first part. The second part, I have to also teach them, okay, having artificial intelligence 4-year course, having data science 4-year course, okay, I have my own thoughts on that. But you as a mechanical engineer should understand what is the implications of these technologies on your products. Yes or no? Right? So that might be taught or not as an engineer. So the mechanical engineer, an example I am giving here, you should also understand these are all the technologies are going to change, and this is the way it will impact my design, it will impact my production. The next is thinking convergence. So more and more you need to acquire that system thinking, not getting too many details here. So without that thinking capability, you can't innovate. If you want to be an innovator, you should understand how to think, right? So the thinking is the greatest ability what you as an innovator have to acquire. It is overall umbrella could be system thinking, then you have design thinking, computational thinking, critical thinking, universal thinking. The snippets of that you have to understand and use it where appropriate. Okay. The next one is the leadership, as I said, how to manage it, and finally, whether it is industry domain, what is that industry related. So if you are not preparing the students and faculty for these sort of skills, now one question, my God, how much time it will take to teach all these things? Now itself we are worried. The academic institutions, we don't have time at all, right? That's where I think the autonomous, whatever the status you have to look at what is that autonomous flexibility you have. Try to see that what is that breadth of these new things needs to be taught to the students so that they become a digital mechanical engineer, digital civil engineer. Now I replace this with this mechanical, I replace with civil, right? I replace that material science and all. So I think the circle is very important, and look at create the skill inventory. So what are all the new skills needs to be added so that when they come out of the academic institution, they become a digital engineer. Okay, I also told that convergence of all these things are not important, not just enough. Right? I told the technological convergence you have to understand as a engineer, right? This is the world what we are living in. Look at here how scary it is. Most of the organizations are bombarded today. I'm saying bombarded with all these technologies. There is no choice. And these technologies are really putting a lot of pressure on the organizations to design new products, to design new processes. If you are in a shop floor, you are expected to redesign the shop floor. But all these technologies will play a very critical role. At least 75% of these technologies are playing a very vital role in the engineering. But how many people, how many mechanical engineers really understood the impact of these technologies today? How many civil engineers understood the impact of these technologies today? Right? So it is very important. So you need to, as a conventional engineer in the civil, mechanical, or electronics, all those guys need to also understand this is what the technological interferences are there, interventions are there. Clear? So if I say you are a digital engineer, this is very, very important to summarize. So if you are a digital engineer, I expect core will be in the middle. Then you need to understand complementary engineering skills. You may not be expert in that, but you understand that, you know the dependencies, you know to know the technological convergence, and you need to have that ability to think as a system thinker, okay? And you need to understand the domain which you are working. Finally, you should also be able to make it happen. It's not only theory, it's not only design, but the design to execution to operationalize is a very, very critical element if you set up your own company. Okay, now, so the title is Engineering a Better Future. I'm just talking here, probably let us say that you can engineer a better product, you can engineer a better processes, you can engineer a better workplaces, whatever. So, one example I will tell you why I'm emphasizing the digital engineering very important. Let us take in the manufacturing company. Okay, how many people know that day by day, companies are looking for a very new role? Your idea, look at these roles. How many people from mechanical here? Anybody? 1, 2, 3, nobody? Okay, you are from mechanical engineering. So did you ever heard these names or did you see this? This is something what organizations are looking. This is the next 4 to 5 years time. organizations will come and ask you, have you built the skills? I want to have somebody, a digital twin engineer, for example. Maybe masters, for example. It will not be like that. Okay, or a smart production scheduler, or a 3D printing engineer, or a sustainability engineer, or a smart safety supervisor, right? So what is the most important thing here is there are new roles, new skills, new behaviors are required. I'm sure Samsung, you might be already doing, your economists might be doing it, right? But what is required here is the academic institutions also need to understand not just simply skill, what roles these organizations are looking for, what the new roles these organizations are looking for. If you look at IT industry, for example, where I come from, everybody talking about DevSecOps engineer or a sustainability engineer. I am not sure whether you are really teaching them all those skills. DevSecOps, DevOps, NoOps, right? Or infrastructure as a code. All these things are new trends happening. So that's where the future, right? So this is the point what I would like to emphasize. Understand the new roles, what is being asked by the industry, rather just saying that we are training in this, that, and all. But align it with the roles what I think the industry is looking for. That will help you even to place better, right? The role is very important. Okay, so the last probably part of the thing, I always tell that if you think traditionally, past 30 years, 40 years, 20 years, 10 years, I think traditionally, but I want to execute digitally. Is it possible? Then it leads to successful failure, right? That means you don't understand the convergence of engineering, you don't understand technology, you don't have a system thinking skills, right? All those things, but you want to have something like a digital product I have to design and manufacture. Is it possible? Right? So that's where what is the most important thing for all Indians is to acquire a new mindset. You want to really change from the existing way of things, certainly we need a new mindset, a digital mindset. That's why I introduced something called lean digital thinking. Digital thinking, right? But why I said lean? How many people heard about lean? Japanese mastered, right? So you just go and read it. Lean is a very, very important thing to reduce your non-value adding activities in your organization. If you are here in this future, what are the non-value adding activities any guess? Waiting time. Okay, conference starts at 9. The speaker comes at 9:30, for example. Don't you think it is a waste of time? We are not. Okay, then rework. You set the seats like this, but somebody come and say that no, it should be like this. That means it is not properly planned. Then the effort is wasted. Whatever you put it yesterday night, somebody came and told him just change it. That is a rework. It is a waste, right? Like that, Japanese mastered in identifying 8 wastes in any organization. 8 non-value adding activities. I'm not getting into detail. So especially in this industry 4.0, society 4.0, 5.0, in the context of this particular technological convergence, engineering convergence and all, you have to identify what are the new non-value adding activities you are adding. Yesterday, Ramesh Babu told me there are 100 sensors, we made it 5 sensors. Don't you think the 100 sensors is a waste of money for a particular product? Yes or no? So if 100 sensors become 4 sensors, it is a very clear indication of the need, right? So that's where what I am trying to tell here is, if you want to transform from conventional engineer to a digital engineer, acquire a new mindset. I call it as a digital mindset. So with that, I'll conclude. So to summarize, I think the world is very different. So we are living in society 4.0 or 5.0. Please understand what is society and its configuration and characteristics and how the society, the people, and the nature and everything communicate. Then you have to engineer new products, new services, new processes, new systems. Your engineering today is entirely different from the past. Your engineering today is the convergence of other engineering disciplines, technological convergences and thinking, and your domain expertise, and also ability to manage and translate to your reality. Thanks so much. Any questions? I would like to thank I think that this podcast is followed by oh, okay, great. Okay. I agriculture. Oh, okay. How it will change the whole entity. Correct. Together and then design. Absolutely. Yeah. Absolutely. That's very important. Thank you so much. Yeah. Thank you. Thank you. All the best, friends. And I think the RFK will start some journey towards society 5.0 or 4.0, whatever we call. They're all that are just 4 or 5. But end of the day, you have to redefine an engineering definition and engineer and start looking for what sort of products and systems you have to design and make it happen. All the best. Thank you.
Thank you so much, sir. May I now request our session chairman, Ratnakar sir, to honor Sri Srinivasa Rao we, as a token of our gratitude. Thank you, sir. Have a 10 minutes break for having tea and snacks.
Sharma sir, good afternoon sir. Are you audible sir? Dr. Sharma sir. Dr. Sharma sir, are you audible sir?
Yeah. Hi, I'm Dr. Sharma here. Good afternoon. Good morning.
Can you start next 5 minutes sir? So we will start shortly sir.
Hello.
Yeah, good. Loud and clear, you're audible sir.
Yeah. Okay.
We'll start. Thank you.
So, what time do we start the session, sir? Or we start
In
live?
next 2 minutes, we will start sir.
Sure. Okay. Done. Yeah.
Excuse me sir, Sharma sir.
Yes, please.
Sir, do you have any presentation to share sir?
No, I'll share it from my system itself.
Yeah, just confirm me. Okay.
Yeah. Yes.
Yes, thank you.
I'm glad to introduce our session chairman, Dr. N. Andachalian, Principal R&D Engineering College. He is an accomplished academician, possesses a rich experience of more than 36 years in teaching, research, and administration in the affiliated colleges of Anna University, Chennai. He holds UG degree in mechanical engineering, master's degree in mechanical engineering, and master's degree in business administration. He obtained PhD degree under the Faculty of Mechanical Engineering from College of Engineering, Guinea, Anna University, Chennai. In addition to teaching and research, he has served in various administrative roles for more than 2 decades. He was a member of Board of Studies of Anna University, Chennai for Curriculum and Syllabi Revision of Regulation 2008. He was a member of Executive Committee for the Controller of Examinations of Anna University of Technology, Coimbatore. He has received funds worth rupees 19 lakhs from AICTE. His research areas includes renewable energy, customer voice and product design and development, materials and operations research. He has led more than 30 UG and PG research projects. He has received Dr. Abdul Kalam's Eminent Leadership Award from the Institution of Engineers India. He is a lifetime member of the Indian Society for Technical Education, member of the Institution of Engineers, member of the AII Indian Management Association, and member of the Society of Automated Engineers. He also holds a Chartered Engineer certification from the Institution of Engineers India. His inspiration is to prepare the next generation engineers with various skill sets according to the needs of the industry. So it's really great to have you with us. Over to you, sir.
Very good morning to all the participants here. On behalf of RMK Engineering College, and on my own behalf, hearty welcome to Dr. Sharma, MBK, Vice President Solutions, Tata Medical and Diagnostics Limited, Chennai. Dr. Sharma is a well-rounded, experienced professional spanning over 30 years, focused on contribution towards wealth creation and IP assets creation, demonstrated through proven expertise in architecting, building, and implementing enterprise class platforms and products, digital transformation, business process re-engineering, and consulting and operations management. Basically, he is a mechanical engineer, followed by post-graduation in industrial engineering from one of the premier Indian management institutes, IIT, with a specialization in operations and systems, and a PhD with core concentration on business intelligence. He has attended leadership programs conducted by well-reputed University of Michigan and Harvard University. He is a fellow member of the Institution of Engineers India, member of Indian Academy of Applied Psychology, and a member of Indian Association of Medical Informatics. Currently, he is working as Vice President with Tata Medical and Diagnostics Limited Company. Prior to that, he was working with the TCS, Ramco Systems, Crompton Greaves, and TVS. Digital transformation in healthcare is a major area in which the companies are focusing, and particularly today's conclave, yesterday and today, this conclave focus on Society 5.0. It is relevant to our topic, particularly related to the society in which the digital transformation is occupying the more space. While healthcare has been a laggard in adoption of modern technologies and methodologies, post-COVID, a lot of profound changes are underway in the healthcare industry, with the digital transformation being the key occupant enabler. With the industry and the education, this type of people will enable the Society 5.0. On behalf of all of you, hearty welcome to Dr. Sharma once again. Over to Dr. Sharma. Thank you very much.
Thank you so much, sir, for the introduction, and good morning, everyone. So the session for today is on the digital transformation in healthcare, which is driving smart personalized healthcare. So the topics, I'll just put that into three parts. One, we will look into why is digital transformation very important in healthcare. Two, what is digital transformation and what is smart personalized healthcare? And three, we will look at how is digital transformation being adopted. DTX is the short form of digital transformation. So we look at how is it being adopted by various companies and countries. Coming to the first part, why is digital transformation required? Let's start with the first principles for a few things. So let's understand what is a healthcare system, what are the challenges and concerns, and where does the problem lie? I hope I'm audible. I'm sorry I didn't ask this question. I hope I'm audible to all.
Loud and clear, sir.
Oh, thank you so much. Thanks for the comment. So this particular slide actually signifies what is healthcare. So it's a set of blind people trying to describe what is healthcare, and every person has his own understanding of what the issue is there. They have their own kind of solutions that is there, and I don't think I could have found a better slide to describe in picture what is healthcare today. Going on further, a healthcare delivery system. Let's start with a quick definition of it. So a healthcare system, also sometimes referred to as a healthcare system or a healthcare system, I mean jointly put together as a word, is the organization of people, institutions, and resources that deliver healthcare services to meet the healthcare needs of target population. So we just start with this basic definition. And a typical healthcare delivery has got three important stakeholders: the care provider, the care seeker, and the caregiver. The care provider is typically the hospital or the clinics or something, and the caregiver is a consultant, and the care seeker is typically the patient. Continuing further, the paradoxes in healthcare you find is, there are three important paradoxes from whatever I've done the research and other things. One is an innovation paradox. See, while the patient has been the center of the universe and all the healthcare is all meant to alleviate the problems that a typical patient would have, but very little has been done towards the benefit of this patient. A lot of innovation has happened towards the drug discoveries, diagnostics, and automation, and etc., which of course have an impact on the patient, but have predominantly benefited the stakeholders like the provider and the caregiver. The second is a resource utilization and the cost. You take a country like India, where healthcare is also a state subject. The government has invested heavily in terms of primary health centers, secondary health centers, community health centers, and tertiary care centers. But because of the lack of adoption and the proper care of the PHCs, a lot of people rush into the tertiary care hospital, choking the system. And people who all can afford go to the private care, to avoid that particular rush. So you find that there's a lot of money that the government has invested, but that has not been properly utilized, but which is actually should have gone to reduce the cost of healthcare, but in turn it has increased the cost of healthcare because a lot of people move into the private care. The third is the treatment versus care. I think people in the north and other places who have seen Munna Bhai MBBS, or in the southern part, we would have seen Vasool Raja MBBS. This really clears what is treatment versus care. So most of the thing is, while oriented towards the care, but what happens today, the focus is more on the treatment. Going further, this is some slide that gives you the where the system is there. The medical mistakes can kill each week to fill about 21 jumbo jets. That's a kind of medical errors that take place. There's a lack of accountability, poor coordination of care, deficiencies in clinical information records, misalignment of payment incentives to providers, little transparency. 25% of all the patients are harmed by medical mistakes. 30% of all funds expended for healthcare are wasted. And these are all some statistics which currently the today healthcare system have got. Going on further, you'll find that the amount of money that is going waste in the US healthcare is about $750 billion. And it's gone, where all it's going to fraud, prevention failures, inflated prices, inefficient delivery system, excessive administrative cost, and unnecessary services. And also, you'll find that 5% of the patients consume 50% of the healthcare spending, mostly on chronic healthcare. And the kind of money that the US spends is about $2.7 trillion goes into the healthcare. Continuing further on the challenges. So one is the inverse care. We just saw that where the 5% is consumed by 50% is. So people with most means, whose needs for healthcare are often less, consume the most care, whereas those with the least means and great health problems consume the least. So public spending on health services mostly benefit the rich rather than the poor. And the other point is that wherever people lack social protection, a lot of payment of healthcare is done out of pocket as a service. And this actually drives people to poverty. The record is about over 100 million people annually fall into poverty because of they have to pay for healthcare. And fragmented and fragmenting care, the excessive specialization of healthcare providers. You find specialties, super specialties, all kinds of things, which is a very narrow focus of the disease control programs, and discourage a holistic approach to individuals and families that they have to deal with. Continuing for the unsafe care, that's what we saw as the medical errors, poor system design that's unable to ensure safety and hygiene standards, leads to high rates of hospital-acquired infections and all. Misdirected care, that is resource allocation clusters around curative care services at great cost, neglecting the potential of primary prevention and healthcare promotion to prevent. So these are some of the challenges, concerns, and paradoxes that we have in the healthcare system. Continuing further, if you look at from a systems point of view, the success of any system depends upon the ability to decompose and recompose elements of the system. And most important, on somebody or some entity having the authority and resource to align. Most of the systems and industries fall into that category, could be automobile, could be aeronautical, or whatever the other industries are there. But unfortunately, healthcare doesn't fall into this category. Many components of the overall system operate as independent agencies. Healthcare reveals itself to be largely a collection of individual clinicians making care-based decisions on their unique apprentice setup. There is no evidence of systemness in the healthcare delivery. For example, even if you take a very complicated and complex thing like an airline, we don't say there is so-and-so is a best pilot or so, though it could be the most largest and complex more machine. But in the healthcare system, we still say this is so-and-so is the best doctor, so-and-so is the best surgeon at all. So healthcare is still a cottage industry, and not all system design and management problems can be addressed through this kind of a decomposition, and healthcare falls into a specialized category called as complex adaptive systems. So typically a complex adaptive system follow these kind of characteristics. One, they're non-linear and dynamic and do not inherently reach fixed equilibrium points. As a result, system behaviors may appear to be random or chaotic. They're composed of independent agencies whose behavior is based on physical and psychological or rules, social rules, rather than demands of system dynamics. Because agents' needs or desires reflected in the rules are not homogeneous, their goals and behaviors are likely to conflict. In response to these conflicts or competition, agents tend to adapt to each other's behavior. Agents are intelligent. As they experiment and gain experience, agents learn and change their behaviors. Thus, the overall system behavior inherently changes over time. Adaptation and learning tend to result in self-organization. Behavioral patterns emerge rather than being designed into the system. And the nature of the emergent behaviors may range from valuable innovation to unfortunate accidents. So there is no single point of control in a healthcare system. System behaviors are often unpredictable, uncontrollable, and no one is in charge. Consequently, the behaviors of complex adaptive systems, CAS as they're called, can usually be more influenced than controlled. So healthcare typically falls into this kind of system behavior. So where does the problem lie? Like all other industries, healthcare, in order to become more efficient, more responsive to patients and other things, they need to have two important things. One is a value driver. The nature and extent of B2C, that is business to consumer service, determines the service value, determines the business to business as well as the value of products and other value enablers. In the context of healthcare, the value provided to consumers and the payment received for this value determine the financial potential for all other players in the network. There is a very important ratio that we use in the study of industries, one that is called as a B2C complexity to the market complexity. This is a ratio. This ratio tends to decrease as markets mature. The most successful player in the market are those who contribute most to this decrease. To accomplish, they usually have to increase the business to business complexity, which often increases the total market complexity. However, this is done in a ways that decrease the ratio of consumer complexity to total complexity. Now coming on to our healthcare, so you would find that an healthcare ecosystem is made of so many people: public, private labs, pharma companies, patients, investors, charities, government regulators, AIM health and medicine, technology providers, insurance companies, and no single industry or a participant has all the assets to solve these problems. So healthcare problems are sometimes also called as wicked problems, where incentives are often misaligned that require collaborative approach to be solved. So given this, so how do we solve this? The potential today we see that lies in the digital transformation, which we will explore in part B. So now look at part B, which is what is digital transformation. So before we go into defining what is digital transformation, let's look at the drivers. One of the important drivers are the technologies. Of course, most of you would know that we are today in the industry 4.0 and we're talking about 5.0 also. The 1.0 we started off mechanization and all. Then there was mass production in the industry 2.0 and 3.0 talked about automation, computers and electronics. And today we are talking about cyber physical systems and Internet of Things and networks. So this has come up because of these kind of emerging technologies. We have 3D printing, 5G, artificial intelligence, augmented realities, automated guided vehicles, blockchain, cloud, cobots, cyber security, digital twins, drones, edge computing, Internet of Things platforms, machine visions, quantum computing, and virtual reality. So these all technologies are one of the important drivers of digital transformation. The second important driver is the business itself. There's a fundamental transformation of business that is there, which is digitization, ubiquitous connectivity, and globalization. Typically, the value that used to be delivered about 30 or 40 years used to be products. People used to sell product and that's it. Then slowly the product era moved into solutions era. So not only we give product, we give you service, we give you spare parts, we give you AMC. So a solution evolved around it. Today, what is being sold is not the product, not the solution, but the experiences. For example, let us take a simple thing like a movie going itself. Today, one can see a movie on a Netflix or something with paying really hardly any amount of money. But then people tend to go to multiplexes, etc., paying 200, 300 or 400 rupees to just get the experience of seeing the movie. So what is being sold at a premium is an experience. So people want individualized, personalized experiences, which is going to be the selling factor. And every nature, and it is impacting every nature of the firm and how a firm creates a value, and no industry is an exception, so is also healthcare. So the value that a company creates or organization creates is through unique, personalized experiences of consumers. There's a centrality of individuals. There was one point of time, this was a famous statement by Mr. Ford. He said, any color of car is okay as long as it is black. Those were days in 1940s and other things. But today we have a 180 degree model to that Model T, where people can choose and the color of the car, the combinations, whatever they got, you can actually design your own thing. So no company has all the resources to deliver these unique experiences. Hence, collaboration is the key. So these are the two important drivers. One is the technology and one is the business, which is driving digital transformation. Let's formally define what is digital transformation now. Digital transformation in healthcare is making use of the latest technologies, methodologies, and processes to deliver sustainable value to patients, healthcare professionals, and healthcare organizations. It's basically about embracing and employing advanced technologies and innovative approaches to maximize benefits. What are the transformation trends like we talked about? Healthcare wearables, data in aggregations, on-demand healthcare, AI screening, patient portals, telehealth and virtual doctors, disease history analysis and all. What are the benefits that people see on a healthcare transformation? Is reduced cost, optimized workflows, enable improved interaction with patients, secure database for electronic medical records. The benefits that is there for patients is better track health metrics in real time, convenient appointment scheduling, easy access to personal health data, better communication with doctors, and better and more personalized services. Just look at the market, what we have. The global digital market size is expected to be about $430 billion by 2028. There's 95% of the health system agree that it's crucial for the organization to achieve investment in digital transformation. There's a 30% increase in the compounded annual growth for the global digital market, and 84% of healthcare providers consider digitization to boost personalization. So given this, let's look at what is digital transformation. So digital transformation is actually a hierarchical thing of three important elements. One is a digitization, where the first step is to digitize information, change from analog to physical form, organize the information properly. Then we went into digitalization, where they automate processes and streamline the processes, where digital technologies and information used to transform individual institutional operation. We are in the third phase of, that is a digital transformation, where a series of deep and coordinated cultural, workforce, and technology shifts that enable new educational and operating models and transform an institution operation strategic directions and value proposition. We are in this phase. Sorry. All of this is resulting in and transforming how we access the care, the front door to care, which is network navigation, virtual triage, and network optimization. The transforming how we pay for the care. This is the fintech for healthcare, the financial clearances, payments, and novel coverage products, and transforming how we experience care. The frictionless encounters of which provided through platform, full stack providers, digital care management platform, and interoperability engines. A typical digital transformation process consists of three important steps: formulating a digital strategy, defining the scope and coverage of a digital transformation, and the digital engineering and architecture. Typically, the digital transformation looks at three important pillars: the customer experience, the operational process, the business models. The customer experience looks at customer understanding, the top line growth, the customer touch points. The operational process looks at process digitization, worker enablement, and performance management. The business models looks at digitally modified business, new digital business, and digital globalization. So these are the three important pillars to arrive at a digital transformation. Now, these are the various applications, digital health applications that we have seen today in the market. For example, the healthcare information, the knowledge generation, knowledge integrators, personal health devices, which include mobile assessment, monitoring and tailoring, telemedicine, diagnostic space, imaging, pharmaceuticals, implantable devices, surgical, personalized therapeutics, geospatial environment. These are all the various digital applications we are seeing, which is driving what is called as a personal healthcare. Now let's look at what this personal healthcare really means. The future physician or the medical engineer is, will physicians become medical engineers overseeing nanobots augmented by smart technologies? For example, a medical engineer hundreds of miles away from the actual point can monitor and treat more than 50 patients at a time. Advanced nanobots can perform medical intervention. And will medical parks unlock remote care at seemingly today unimaginable scale? Then we have got the future smart homes, where there's a genomic sequencer, scans breakfast, checking for signs of E. coli. You could have smart watches for monitoring lethargy, smart tattoos, which can measure the blood and tissue recordings. And there are 5 irrevocable facts that continue to force a shift in the industry traditional models, which is smart health. One is the socioeconomic factors. Care will continue to take an even large share of GDP as obesity and chronic diseases are increasing, so which will require a greater proof of value. Required capital efficiencies. Pressure moves from productivity and efficiency challenges to innovation with intelligent modernized infrastructure. There are enormous amount of workforce shortages. 18 million predicted shortfall in global health care force by 2030, which will need a shift towards virtualization, automation, AI, technology integration, conversion to virtual, personalized and preventive models will require integration of new capabilities. And consumer acceptance of smart devices to require care will reshape care delivery, which will require change in business and clinical models. You will see that because of these, we see 8 key changes in the traditional health model. 1, the point of care is shifting from hospitals to home. The data ownership changes from institutions to consumers. The reference point is population to individual, which we talked about the personalized healthcare. From a physician's role, authority to a guide. Data interrogation is separated to integrated. Interactions become more from physical to virtual. Access times become from availability to on demand, the structured arrangements to fluid access, the collaboration. So these are the kind of changes that we are going to see with the technologies coming in. And also the healthcare data is growing up enormously. the growth in the volume of data is 6% in financial services, whereas it's 36% in the case of healthcare data. The 1 trillion sensors in the world in 2020, which is growing at 185% since 2010. And in 2021, every person on the planet generated about 50 terabytes of data. So you'll find that's a huge amount of data that is being coming to the system. And then you would also see that the future, we will continue to see new technologies, the cloud computing, sensors, 5G technology, and virtualized will now shift to quantum computing, the spatial web, the web 3.0 and metaverse. So medicine will no longer be a clinical science supported beta. It's already moving to data science supported by clinicians. You'll see a lot of Internet of medical technologies coming in at the personal level, in and outside the body. You have smart patches, smart clothing, embedded pills, smart dust, biometric tattoos, nanobots, etc. Your smart home, you have sleep and nutrition trackers, motion sensors, autonomous vehicles with sensor arrays connected to smart city infrastructure, smart furniture, ambient vital signs sampling, virtual assistant, connected appliances. Then you have a smart specialist care facility with AI-enabled robots, drones, and virtual assistants, AI surgery platforms, integral comprehensive diagnostic environment, IoT trackers, 24/7 virtual care monitoring, and always an access to multidisciplinary care team. And today AI is getting more and more promising. So you'll find that the FDA approvals for AI algorithm is increasing over time. About 275 AI algorithms have been approved in 2017. As early as February 2022, we have WITS.ai wins approval for AI that detects cerebral, this one, the algorithm input for cardiac imaging. So a lot of AI algorithms are coming in to help the clinicians. Basically, what we are seeing is this data is playing a very important role to deliver personalized healthcare. There's an access to data, connect the data streams, analyze the data streams, create value, combine the data sets, analyze the data sets, create more value, share access and insights, analyze the data insights, create more value, target therapy and care, make care more human. So this is what is that we are trying to see in the future coming up, where there is sharing of insights and continuous learning. And data and technology, continuous learning becomes more intelligent and the health value is increasing. So what we are essentially seeing is an ecosystem of these things coming up, where you got sensors that systems collect and personalize data. There's a smart comparison to patients' baseline and real world evidences. And then there's a personalized actionable insight that are generated, which give informed clinical intervention, continuous monitoring via sensors, optimization of personalized treatment, where you can adjust the doses and all. So what we're looking now is, can AI be able to simulate human behavior in terms of sense, perceive, learn, know, reason, plan, and act? So we got multiple AI technologies which you know of: constraint satisfaction solvers, path planning algorithms, knowledge graph, ontologies, machine learning, etc. We got enormous amount of use cases like digital triaging, care pathway optimizations, behavioral coaching algorithms, remote patient monitoring, smart risk monitoring, in silo testing, smart trial recruitments, fast deeper genomic analysis, real-time disease management, and all. So essentially what we are moving out is from an analog sequential care to a digitized care to a connected care and a smart health system, which is actually pushing and pulling data to and from the edge. Patient is at the centers, silos between care settings are completely broken down, and a connected healthcare is being given. So the intelligent ecosystem is actually going to be hyper-connected with superfluid data flows, have fast real-time operations, operate human AI, deliver personalized care and health experiences. So in summary, the data is the fuel, the science and technology compromise engine, the insights are personalized, measures are equally clinically and non-clinical, and the user experience device, which is demonstrated by the health outcomes. So all this is resulting in what? It gives access to real-time healthcare information, data privacy, remote patient monitoring, preventive care, and better ROI, eliminates human errors, timely assistance, improved care to patients, efficient healthcare analysis, and efficient patient engagement. So now we have seen what is smart personalized healthcare. Now we go to the third portion, which is how is adoption of digital healthcare. Let us take our own country of India. I hope most of you heard of National Digital Health System, which is announced by the government, which is a combination of several of these entities, hospitals, clinics, labs, third-party insurers, health tech companies, modern medicines, practitioners, all these people. The objective of the NDHM is to create an ecosystem that supports universal health coverage in efficient, accessible, inclusive, affordable, and timely and safe manner through provision of wide range of data, information, infrastructure, duly leveraging open, interoperable, standards-based digital systems and ensuring the security, confidentiality, and privacy of healthcare personal information. The typical framework looks like this. The government-owned organization will drive the policies and everything. There's a governance structure. The vision is to be the best healthcare network globally, to provide every Indian with access to digital health services. The services will be PHR, which is personal health record, registries, health IDs, open API, data management, technical architecture. The two important domains that they talk about, the health domain and the technology domain. And the objective is to ensure availability of services on wider scale, to address human resource gap by efficient and optimum utilization of resources, to provide healthcare services in remote and inaccessible areas to telemedicine, to improve patient safety, to monitor geographically dispersed tasks for meaningful field level interactions, to help in evidence-based planning and decision making, and to improve efficiency in imparting training and capacity building. So if you look at the principles and the architecture from the tech standpoint of view, the domain principles and technology principles will more focus on the technology principle. This is how the architecture looks like. There are five layers. The bottom, we have the infrastructure layer, the data hubs, the technology building blocks, the application building blocks, and access and delivery. We'll see each one of them in brief. The infrastructure block talks about the secure health networks, the health clouds, security and privacy operation center. The secure net health will be provided, will be a blueprint which will run on the VPN for specific applications like telehealth, teleurology, which requires like PACS and all. The network would be specially designed. There'll be a health cloud, which is health cloud, which will be built by MIT Initiative Government Community Cloud, which will provide the health cloud. And the security and operation centers will provide all the security and the privacy things that are required to drive this. This is layer one. The layer two talks about the data hub, where we talk of personal health identifier, the personal health record, and the health master directories. The personal health identifier is the unique identifier for every patient and for every citizen rather. The health record generates an aggregate health records for a person and puts the information control a person to share it with consent. Healthcare provider expected to identify the individual through PH, insert a medical record into person's PHR after providing care. There's a DigiLocker system that is being there, where multiple users and users can exchange data with consent. And the health master directories will be there. The directories will be disease registries, donor registries, facilities directory, doctors, nurses, paramedics, etc., which can actually help in actually optimizing the resources. And the directories will build a strong ownership and governance mechanism and adhere to the principles of single version of truth. We come to the third layer, which is actually the technology building blocks, the anonymizer, which takes data from the health locker, removes all personally identified information to protect privacy and provides anonymized data. Consent manager, which takes a consent whenever any record has to be exchanged. Health locker, which is a standard-based interoperability specification to hold various records. Health information exchange provides a protocol for exchanging healthcare information across applications. The health analytics provides a decision support for stakeholders on variety of themes by aggregating data sets and all. We have the layer 4, which is application building block, where the applications can run across emergency care, healthcare, wellness, medical education, etc. And there will be government managed healthcare applications like reproductive and child healthcare, NextShy, or you'll have health information system like Raktosh, or National Program for Control of Blindness. Like these are all various applications managed by the government. You could also have the private sector applications also interacting with all these things and all. And the layer 5 is access and delivery. It could be the call centers, India Health Portal, the social media, and My Wealth apps and all. And all of this is driven by the vertical layer of national health standards, command, control, and communication center. So this is in brief about the architecture of what is there. It has got the 5 layers, the national health standards, and command, control, and communication running across all the 5 layers. Now let's look at what countries like China and etc. are doing. The internet future, they're also looking at smart city. The government functions, policy making and all is governed by them, like our NSDM, smart healthcare service system, disease prevent and control system, emergency medical systems. There's a smart city healthcare platform for disease control, remote diagnostics, remote treatment, supply chain, smart health and insurance and all, which is leveraging 5G, cloud computing, AI, VR, big data, Internet of Things. Now let's look at some of the big tech companies. What they're doing is that, for example, take a company like Amazon, and this is as late as 2022. So they're more into building for consumer care provision, for consumer and employee health. They bought over One Medical, and these are the various companies that they have made investments. Diagnostic and therapeutics, these are the various companies that they have made investments, and they have a partnership with Martis. Care coordination and remote monitoring, they have Harmony Health, Clinic, and other things and all. So these are the ecosystem of applications that Amazon is building for consumer care provision. Let's look at what Google is doing. Google is targeting life sciences and data. So for AI drug discovery, R&D and all, they got this set of application. They're partnering with these people. AI radiology and imaging, they got various of these applications. And they're also tying up with Mayo Clinic and other things. For medical data, they got these things. So this is how Google is targeting life sciences and data. Microsoft is prioritizing provider development tools. So they would like to provide tools for development for building very, very innovative applications. Clinical IT solutions, they're partnering with these people. Diagnostic and therapeutics, healthcare enterprise cloud tools, healthcare enterprise IT. So this is the ecosystem of what Microsoft is investing in. And if you look at Apple, Apple is focusing more towards consumerizing of the healthcare, offering a lot of apps for fitness and other things, so their wearables and integrations and everything and all. And it has got 51 like activity tracker. It has got where your activity rings, coaching, etc. It can do. For health heart, high, low heart rate notifications are there. ECG app is there. Things, mindfulness and education, COVID-19 related things, hand washing and safety, sleep, respiratory, mobility, hearing health, women's health, medications, and there are a lot more other apps. So they're focusing more on developing apps which can enhance the consumer and empower the consumer in doing that. Oracle is focusing on centralizing the whole thing at one place. They're taken over Cerner very recently. Providing and put a lot of investments in the cloud to provide that. So this is how the big tech companies are doing. And let's look at what the future of healthcare is done. This is the study done by the Economist. So what they did was they empaneled experts in the field of healthcare to predict what technologies and innovations they will see in the near term, that's the next 5 years and next 25 years. And then they surveyed about 400 odd global business leaders in healthcare and found out whether they agree or disagree in what kind of things they're looking for. In the US, in the next 5 years, you're looking at genomic analysis, AR and AI and medical decision support. And in the next 25 years, you're looking at designer babies, nanotechnologies, and hospital redesign. So is also European EU, which is looking at genomic analysis, robotics, and AI and medical decision support, looking at designer babies, aging research, and brain-computer interfaces. Asia is no different. We're also looking at designer babies, 3D printed organs, brain-computer interfaces, etc., and all other countries. So there's a tremendous amount of shift that is happening in the way the healthcare delivery is going to happen. There's a paradigm shift in which each one of us are going to experience. And the key thing is going to be personalized healthcare, moving from illness to wellness. So that is in summary of my presentation of part A, part C. To just summarize, we saw why is digital transformation required in healthcare, We also looked at what is digital transformation, what is smart personalized healthcare. In why we looked at why healthcare is still a cottage industry. It doesn't follow the generic system rules. It follows a complex adaptive system. So that's why digital transformation play a very vital role, and that's what is being done today. We looked at various technologies and what are the processes and what the digital transformation is all about, and how these technologies are driving smart personalized healthcare. And we also looked how various countries and technologies are adapting. We looked at India, which is going a major way through National Health Digital Mission. We're looking at big tech companies like Google, Amazon, also acquiring and building up with their own ecosystem in the healthcare. And the next, how the future is going to look for. So this is in summary. And thanks to the entire team of RMK and especially Mr. Chandrasekhar Kesavan for providing me this opportunity for presenting this particular session. And thanks everybody for giving your time. And that's it from me, sir.
Thank you, Dr. Sarma, Vice President, Tata Medical and Diagnostics Limited, Chennai. In fact, you started from basic thing, that is, what is healthcare, what are all the components, starting from care seeker, care provider, etc., to healthcare delivery, what are all the challenges and the concerns, to the next stage, drivers of digital transformation, and what are all the technologies involved, and the 3 Ds of digital transformation, that is DTX, various digital health applications, India's current healthcare system, big technology companies like Amazon, Apple, Microsoft, what exactly they are doing now, and the future of healthcare in the world. Now, all those things, various aspects, we have covered everything. Thank you very much, sir. On behalf of our management, I thank Dr. Sarma for allotting time for us and giving such a valuable and insight about digital transformation. Thank you, sir. Thank you once again. Thank you.
Thank you so much, sir. My sincere apologies for not being in person because I'm a little unwell. I had a knee surgery about 3-4 weeks back. Otherwise, I would love to be in person there and meet you all. I missed that opportunity, and my sincere apologies. And I hope the session was useful and we could make some difference and understanding in what is digital transformation. Thank you so much, sir.
Definitely, this session is very useful. And our next speaker is, thank you very much, sir. Thank you.
Thank you. Thank you. Please.
Our next speaker is Dr. Jayanti Parthasarathy, Department of Radiology, Nationwide Children's Hospital, Columbus, Ohio, from United States. I am very happy to introduce her. The previous speaker, in his speech, he questioned about the physician turned future biomedical engineer. Actually, she is the person who was the surgeon turned additive manufacturing specialist. She is a specialist in 3D printing, etc. Dr. Jayanti Parthasarathy is a trained dental surgeon, having practiced dentistry in India for more than 3 decades, transgressed to additive manufacturing for clinical needs after completing masters in mechanical and manufacturing engineering from College of Engineering, Guindy, Anna University, and she pursued PhD at the University of Oklahoma, USA. She has been at the cutting edge of 3D biomodeling and 3D printing to arrive at patient-specific solutions for complex surgical challenges in the adult and the pediatric population for more than 2 decades, in specializing in development of patient-specific devices using advanced design and manufacturing technologies as 3D printing, with in-depth knowledge and experience in navigating FDA approvals for medical devices. She has won a lot of awards and honors. I'll just name a few. 3D printing, dental and medical pioneer of the year 2020. Outstanding PhD dissertation award in 2009-10. School of Industrial Engineering, University of Oklahoma. Design, analysis and fabrication of porous titanium implants using electron beam filtering for craniofacial applications. In 2008, Dick Aubin Distinguished Paper Award SME Rapid Conference and Exposition 2008. Founder President Award of the Indian Society for Dental Research 2001. Fellow of the Indian Society for Dental Research 1999. Captain Dr. J.J.S. Gangadharan Memorial Award in Orthodontics 1998. Jawaharlal Nehru Memorial Fund Award for Meritorious Students, Madras University 1973. We are all very fortunate to have such a very eminent speaker before us. On behalf of the RMK management and on behalf of all of you, hearty welcome to that for us. Wonderful. Thank you.
Thank you, sir. It's really great to have you here, ma'am. As a token of our love and appreciation, may I now request Dr. N. Anbachalian, Principal, RMD Engineering College, to honor our resource person, Dr. Jayanti Parthasarathy, Department of Radiology, Nationwide Children's Hospital, United States, the shawl and momentum. Thank you, ma'am. Thank you, sir.
Good afternoon, everyone, and I really appreciate the opportunity to be with such an august audience. And I'm really humbled with the great elaborate introduction which Professor gave us. And thank you very much. I really appreciate it. To make the presentation to come on. We'll be hearing a little different talk about digitalization. I've always been very interested in digital transformation of images. I don't think a lot of people are talking about big data, the patient health recovery. But for the past close to about 35 years, since 87, I've been looking at transforming images. Like first it was X-ray for about 10 years from 87 to 97. And it was a time when I came back from UK after my training in orthodontics. I went to the CAD center and said, teach me AutoCAD. The person said, no, you're a doctor, you cannot learn. And give me a problem and solve. I said, I'm a doctor, I'm going to see different problems every day. And every day I'm not going to be at your doorstep asking you to teach me. Then I decided, okay, there's one thing I tell my students, there's nothing what you can not learn. You have your mindset and you'll definitely be there. And the man above, God, will send you the right person to guide you at the right time. That has been my life experience in every walk of my life, whether it's my profession or my personal life. So then I'm trying to get AutoCAD 2.0 and then trying to get a computer from HCL. HCL took me 1 whole month to discuss what is the configuration of the computer that I was going to get. And those days, believe me, I paid 1.5 lakhs to get that computer. In 87, it was a lot of money and it carried a lot of value. And you could get so many things like that. But they did a very good job. And those were the days when you buy a computer, they will give you training for a week to use how to use a computer. One day would be DOS operating system, one day they'll teach you Word, one day they teach you PowerPoint, another day they teach you like Excel and spreadsheet, and people would start using them. I started using the computer that way, but then I started learning AutoCAD. I had a friend of mine who just then got introduced to me, and we started writing programs together. And as things should have it, he moved to UK in 6 months after working with me. Then I was left as a fish in the pool, trying to swim by making my own programs for all my needs. Then in 97, I went to see Dr. Chandrasekhar when he was at AEFRG Center for CAD-CAM. And he said, "Ma'am, you've done 2D for 10 years, now it's time for you to move to 3D. I said, "What do you mean?" But I had already seen these stereotypical small graphic prototype models in 95 a conference in Berlin, and I was really made it how did they even get here. Then the next day I went to see the AEFRG was getting directly on printer that the next day it was being installed. I went to see them, I saw them printing a manual. I was a surgeon at Mullen Hospital, so when I said, okay, here is a solution for my patients. Because I used to dissect a part of the jaw with a tumor. When I saw a mandible on the lower jaw being printed, it took me to a nice job. I said, here is the solution I have for my patients. So I started adopting that in 97, 98. And those were not the days of digital X-ray. We used to have those sheets of the CT scans. Then myself and another professor at AEFRG, Mr. Gunasekar, we used to scan those X-rays for those CT scans, do noise reduction program. We did everything down the earth to get a 3D model. Then, and I started speaking a lot. In 2003, I decided this is the technology I need to adopt and go more into it. And Anna University, Professor Gauri, the current Vice Chancellor of Madras University, was very kind enough when I asked him, "Sir, I need to do a program here." He said, "Dr. Pumulathakaram, but I can't take you for a PhD because you don't have an engineering bachelor." I said, "Sir, I just want to learn the technology. I just want to see how deep I can go into it." He was very graceful. 2 weeks later, I get a letter saying, "Take this entrance exam." I'm like, where do I go and write an entrance exam with all of the engineering lecturers and pass out and come and join? But as I said, God was there with me, gave me that opportunity to join. I was probably the first entrance to do a master's, a doctor without an engineering degree, to do a master's in engineering. I'm very thankful to all these people who have walked along with me and brought me to where I am to justify for me to come and talk in front of I guess big engineers who teach engineering to talking about students. I'm very, very thankful for the opportunity. And I thank R&K organization and all of you for having me. I just kept you engaged until my presentation was getting very trying to tell you a little story, which could put a little thought in some of your minds to say that that's the way you come out of college. You come out of college, you think the whole sky is under your thumb. But it will be under your thumb. If you really have the intention to, you can get where you want to.
What am I talking?
This very clearly shows that we have the best of minds here who can help us in terms of crisis. Without this PowerPoint presentation, I wouldn't have been able to show you anything. I'm okay. Okay, let's get started. And my topic for today is going to be apologies for the late start. Let's get started. The topic for today is going to be 3D biomodeling and visualization. We all go into the surgery. Anybody who goes to surgery, it's going to be a not only the patient. So can tell me. So, what family is really scared of the one that goes into the room, then the top, the rest of the can hear, right? How can you hear me? Can you hear me? My topic for today is going to be 3 modeling, 3 things. Visualization. As we said, when we have the very not only the patient, so also discuss the situation, but the third is not see what is going to see. Butterflies are logo, so we all fly. Today's learning objectives will be learn to understand a little bit of what we expect from Society 5.0, and we're gonna, this is going to be a 30,000-foot overview. It's not going to get you into the details, but it take you to walk through to what the tip of the iceberg. Then you're going to integrate technology, and you will all come in to every part of developing the program. And we're going to understand what sterilization is technology will and what is going to work you. And just let's define certain personal medicine. We want to talk about personalized medicine. What is personalized medicine? Basically, using patients' unique data, whether it's images or it's going to be their healthcare data or their personal data. We are going to derive a treatment plan or select that data and analyze. Innovation is what we are looking out for next generation. Give us under the guidance of our current professors and outcome is the result of the treatment. This concept, and it can be in various ways. It can be elimination of the disease. In certain times, it is just a reconstruction of destroyed energy. Say, somebody has a tumor. If you remove that tumor, if you can remove the tumor. So, reconstruction is lost. Somebody has lost a part of the leg. Reconstructing it. Making walking. This is the one message of the how fast you can walk, how fast you can walk, how much less pain you have, all that will be a message. And let's say some form and function which are being talking here in the engineering world. Innovation has not the performance has also to the function. Human body notice. The hospital stay. Every day a patient in the hospital costs a lot of money. So we want to keep the hospital stay cost of money. So in the US, you say, for no surgery, patients get the hospital for more than 5 days. Once it goes more than 5 days, the cost can be longer. Even a cardiac surgery, the 4th day they are discharged. When they have open heart surgery, 4 cases till they go. We have a second section next till they go. So they keep the hospital very minimum. Then we have, the work schedule, the cost factor. Trying to get back to me. A person is working and if he has a surgery and he is going to be away from work for about the whole month, he has so much loss of productivity, which is taken as a benefit. Then the anxiety starts with the family and about patient satisfaction, some of these metrics we take into analyze the outcome of it. When you look at patient trials, there are 4 clear parts. One is personalized treatment. The doctor predicts to see how the treatment is going to work with the patient. Then he's also going to talk to you about preventive treatment. If he diagnosed you as a diabetic, he's going to say, don't take sugar, don't take oil, don't do that, all these are preventive methods. Then you expect the patient to participate in the treatment that you're going to do, because only a compliant patient can become more happy. So how the screening biomodeling and everything is going to help us in that process. There is a paradigm shift in to get better outcome. Now the radiologist or the person who takes the physician who reads your X-ray, CT scans, MRI, he is the enabler. He is the person who helps the surgeon to visualize or see what is needed. The enabled is the surgeon and the patient is also enabled. So the patient gives an informed consent. Before the patient goes into the procedure, he understands what is going to happen to it and what is expected out of it is what is missing. So you have a better patient compliance, better outcome. Radiologists and the surgeons in different ways. Radiologist is trained to convert 2D images in his mind into a 3D volume. But whereas the surgeon is not. The surgeon sees what he opens up. He sees the person physically. So he doesn't know how it looks like on the 2D. So the same problem, 2 different people look at from different perspectives. Again, radiologist tells the story from images. The surgeon is he's very hands-on. He's ready with the knife and his scalpel. And he just cut the patient and see what's inside the decision making support, you have the CT, MRI, you have ultrasound, then you have other images, you have the 3D markers. Problem statement is, as we said, the surgeon sees anatomy in 3D, and so he doesn't know much about it. Before he goes into the surgery, he doesn't understand so much of what he likes to understand. As a surgeon, I've been in that place where I really know what my surgeons are looking out for, but they really don't have the opportunity. And then this leads to making decisions on the fly. In the OR, when you're operating, you have to make your decision. It has to be quick, it has to be the right decision, and because you cannot go back on it. Because if the decision does not work in the patient problem, you have to take the patient back into the operation theater, second surgery, which is not solved. And increase surgical time or your surgical time will go from 2 hours to 6 hours, which is again not good. And these are today I call what's called Googlacharya. So you have a question, you say, hey Google, give me the answer, and there you are. But the surgeon doesn't have the start. You cannot go on to surgery.com and say, what should I do here? Probably we might have, as we look into big data in the next 20 years, 30 years, the outcomes of all of that might be able to have one. And all this leads to suboptimal critical outcomes, which you want to. Solution is patient-specific enhanced visualization. Make them see as much as they can so that they understand the difficulty more. They understand what the underlying problem before they get into the surgery. But dealing with life and human beings as a surgeon. Okay. Enabling technologies, you're all very familiar with there is no CT or MRI without the engineering world. There is no advanced image processing or segmentation as we call without any of the software programmers, and today AI is taking up a lot of it. So that getting into more of automated segmentation, and then the 3D biomodeling, where within a few seconds you're able to get these models. These models can be put into augmented reality or virtual reality, where I'll show you a video later how two people can collaborate with them. And they can also be got into 3D printing. I saw your ideas lab, which is going to be inaugurated tomorrow. So yesterday, and it was just so nice to see the 3D printers and the scanners, which is all very clear. And that's when I just told that we should have a strong healthcare connection. The press of a button does not give you a 3D model in the medical world. It starts from just like your 2D drafting, and then you get the 3D model. Here, our input comes from the CT scan, the MRI, to create a 3D virtual model. And from the virtual model, there are certain things which you might have to add for structural stability and do all that. Get the approval from the physician before you go ahead and print it. You have a printing system, post-process, and then you deliver to the physician. All this means that you're going to add errors in each of these procedures. So that cumulative errors cannot be beyond assessment. So a very good quality system is very essential so you can get the right model. Virtual to physical transformation, where you have a virtual model, you have the printing process happening, and then as the full job is completed, you have the external support. Now you put all those together by means of magnet. So the surgeon sees the whole thing, or he can split it as now he can measure from his access point. The pink part is actually the tumor. So you can design his access point and see how far he has to go. All specialties of medicine can are using 3D modeling. What can you do with this? You can do anatomical models, you can do virtual physical planning. You can do the surgery on the computer and then decide which is the optimal treatment plan. You can plan your surgical guide so that just like the gym once you open up, you can put the guides on the patient and then do the cuts and then finish up your surgery. Implantable devices, patient-specific devices are very effective. We've done a lot of them for the past 15 years. There is, now we see what is the specialty what uses. There is a congenital heart defect. As I will tell you, the two blood vessels are integrated. Each one should be in one chamber, but they're all in the same chamber. It's a very complex situation for the surgeon. And so, and there's also a hole in the heart, which is got to This is an, as you can see in this slide, there's an extension. So now you're going to see it in the extent. You've got to do the right sizing. This is another critical planning where they wanted to do not an open surgery. They're going to do an intervention surgery. But once we made the model, we were able to understand that it's not possible for them to do an intervention. The person has to go for an open. Another very difficult situation. This kid is hardly 5 days old. So you can see how small the building fruits are going to be. So where there is difficulty in such little children, the structural also is also small. The pediatric world, another challenge is these kids are growing. So the size changes. And it's a very small market. So the big players do not want to come here and spend their time on money. So a lot of times, one of the this is a human brain, where you see here the neural tract and parts of the tumor. So those spots are the magnets. Then you see this is a nerve tract. So when he is attending at this human, if he hits this nerve tract, he's going to injure either the vision or the movement of the person. Depending. So these ones, you build them one to one, and over here you've seen the accuracy to be at less than 0.1 millimeters. So I think I will do that. There is all these patients. They can never see before this surgery. They cannot see where the teeth which are going to grow in the side. And when I grow the side, they can't see. So during that surgery, it's very important. There is a tumor which is affecting the brain, the nose, and the mouth. So there are 3 teams of surgeons. There's going to be a plastic surgeon, a neurosurgeon, and a clinical going to operate. At the same time, the kid is 3 years old, and so they need to understand where each one is going to be. Who's going to start first? What's going to be done? This is very useful for them. Trauma reconstruction, this person had a gunshot and the mind was all these little pieces were strewn all over the doors. What we can do in a virtual surgeon, pick up each of those pieces, put it together, see how nicely from here to we have reconstructed. Now we can make this, take the model, and we can actually bend that clip before they go into the surgery. So that can be used as a template for this. And you can give a different color for each of those segment parts. This is a destroyed lung. You can see the extent of this. This is again a very complex surgery where they do a very minimally invasive surgery, just the 3 millimeter keyhole. This is actually, there is the urinary tract, the fecal tract, and the uterus. Everything has one common arm, which is very complex, and they have to operate the patient. And most of them also have spinal defect, so they cannot carry forward. once they have this model, they have something in that before they go into. Here is a top foot where you can see that. There are a lot of missing bones. So now this model, we built this with, these studs will have the flexible material. This will be hard material just like bone. So they can actually move each of those joints and see how they need to reconstruct. It's very disheartening to see, but fine uses like this. This is not a 2D curve, it's a 3D curve. Goes in all kinds of directions. This is the all from the head end to the foot end is so far. So how are they going to make these children right? How can they even see how these this was a very interesting thing. This is not patient specific, but it is how the family education is there. There was a blind, a visually challenged couple. Both the mother and father could not see anything beyond the shadow. They were going to have a child with a very complex health problem. And that child will need surgery the day of the birth. So how are we going to explain to them? The family said that your child is having a problem. So they came and asked me to do something. I said, okay, let's use the brain. And people are very good at brain. So we created these models. Here you can see, this is a normal heart. So you can see that the two chambers are nice and white, raggy, here you see, this is very small. But small. So we gave different textures, each of this, and we made the heart structure as soft. So they could pass their hands on and see what geometry we were talking about and what was the problem. And they were so grateful. The child had 4 surgeries within the first 6 months of life, and for every surgery we made this, and they were so happy. So the first thing we did was thank the English. We were able to translate all this in grade in our department and read it. It really made a lot of difference in their life and their time. This is a unique opportunity which I had. We had a conjoined these kids are joined all the way from the chest to the pelvis position. You can see they had 2 different hearts, but this particular child, disease children, had one liver. So the doctors had to split the liver, and the pelvis was also split. So they had to do a very complex surgery. Surgery took about 32 hours. Otherwise, it would have taken 48 hours. With the model and about 6 months of planning, the surgery took 32 hours. And we had, I think, about 38 people on the team who were operating at different times through this. If you want more details on that, they are called the Mata twins, MATA Mata twins. And you see that they are operating at Texas Children's Hospital. And now you can see how happy the kids are separate. That's the parents are happy. Okay, whereas one, then from the CT and MR, we built this model. This is our digital model. We took the CT scans and the magnetic resonance scans. We built it in such a way that we cut the forces and they separate each one. So exactly the way they ought to be separated. So we gave them a guideline. So and we also put the liver as it could be picked up when they wanted. they wanted to see the structures behind, they would be able to separate the liver. And we found an avascular region, that is, avascular region where there was least blood supply, where they could cut the liver and split it and have a glucose. Now these kids are in elementary school and they are so proud to see that. And I happen to be the three morning and 50 years. So they are very unique and great opportunity. Now we go to virtual surgical planning, how you can do the surgical planning, then you can do for all kinds of surgery, brain tumors, dental implant, a lot of people use. Orthopedic tumors. We recently got a paper on that. Here is a liver tumor. So the surgeon needs to cut this part and take this tumor out. And how these blood vessels are going to place, give them a 3D virtual model, which they can move, rotate, and see. They can switch on and off any of the parts, and then they can see exactly how they need to do. There is they're going to do what's called a they're going to just like to have the we use these to call distractors. This trajectory is very important to see how you can move these particular things. Because the surgeon came to us saying that I'm going to take 10 millimeters of this bone, identify the right spot. Right? I'm going to reconstruct it. But when we actually did the virtual surgical class, we told him that 10 millimeters was into the 21 millimeters of whole body. We want an appropriate place for it. Very happy because otherwise he had cut only 10 millimeters. It wouldn't have been enough. Then you need to go more. This is again where you see. This is a bone from the leg is being reconstructed for the jaw. You can see the complex shape of the lower jaw and a straight bone. Now we are going to cut. So what is the angle that? And this also has to serve as a component for the upper, where you put the teeth and the patient. So it's very complex and so these guides work very well in that. Here you see this is a huge big pelvis tumor, and there's no way in which they can see how much is in any of the other disorders. So they have a physical model they use to see. I'm going to cut the bone here and have some gland of it. But this is a one-to-one picture. Now, so this is a one of the defect. This was the defect in the class. What is the exact? Methods are very happy to work. This guide prevented reduced 2 brain operations to 1. So we made the guide and this is being done in one go. So we're able to open the skull, put the guide, look at the section, and then it implants back. But otherwise, normally, first stage, you do the tumor section. After 3 weeks, you do another brain surgery. Why one brain surgery? Planning. So, my colleague, we work, you can see how he's putting a stem. But the other two are the cardiologists. This is the person who's going to do these surgeries. So how interactive it is, how they can understand each other. It's a very powerful thing. So they're able to compare two patients at the same time. having the same problem but different. But simulation is another very important thing for treatment planning, where I also work on mechanical properties to equate to that of patient. Yes, you can see this is a blood vessel is called the pulmonary artery. This is connected to the flow pump and your CRT is the same. So you can see the flow. This we can simulate the patient's as pressure and other things. This is another, this is the class of 10. These are my class 10. So you can also do some clinical trials with patients such as one to get the right result. So we use these bonds for teaching. So we make all these bonds with exactly the you can see these are my below trying to understand the anatomy. Oh, yeah. Sorry. Okay. This is a lung surgery where they have to remove a part of the lung. So and this is also minimally invasive. So they're going to remove a part of the lung with just 2 millimeters of the critical weight. So we use this for fellows and skin like skin and sit on top. So now you can see how skin properties and matrix composition becomes very. Here is my ENT surgeon. He's holding one of the board and putting a stent into the ear. In the US, you say at least about 85% of the children have ear infection. Not sure whether or whatever. A lot of them need the stent. Possibly colleagues which we do. What's the advantage? We have the physical mod that has to touch the constant. We're also used to touching. Talk about the digital world, but there is a different feeling. And so then patient education and better compliance, we already saw that, and surgical rehearsal and team for good cosmetic results. Reduce operating time, predictable outcome, reduce the process. No thinking on doctor. So now, I don't have to talk a lot about it, but where are all of them? We use a Polytech machine where we can combine principal and end product will have mechanical properties. That is the different types of things are from here. You can use one type of color, one type of color, one. This is a very fine very, black color if you use for printing, fire plotter and fire not you're talking about it. These implants were made, this was made in 2008. This is absolutely fine. Every time I come, I talk to him, and I started making these bigger implants from titanium mesh in 2005, and now it's most of the 17, 18 years, they're all doing fine. This is a 3D printed, and this is one of the parts from my PhD research where I worked on ladder structure, mechanical properties. So 3D printing lends itself very comfortably to engineer mechanical properties. So this is another publication where we did the from the geometry factors of the part. Titanium plant. Here we have PCR, augmented reality, we see the method on and how we be able to work and create those structures. Very powerful, very powerful. And I have my neighbor is sitting in one corner of the hospital and I have a cardiologist sitting in another part. Both of them together are collaborating and talking. The conference is happening in an auditorium in Turkey. So you can see one of the radiologists locations and how they do it. It gives a lot of interaction between people and between the physicians and the what makes a successful program? We all spoke about TQM. Protocol very, very important. As you know, there are so many steps to do. Start to right transmission selection. Your image data must be right. Your program must be the first one. The person who is doing the second mission must be right. Then, as you know, there's molding and mapping into what. Then the printer has got into its job. And the post processing is equally important. So we cut off some very thin parts of the during the post processing disaster. So in all of that, you need quality. Believe me, the surgeons are very picky. One wrong case, you're not going to get the surgeon back to you again. Because I completely agree. If I were in his place, I would do the same thing. Because I'm dealing with patients. Living people whom you got to be very careful. Put yourself in the patient's position and see. If you accept that somebody did something wrong to you, just because it did not work, or somebody did something wrong, no, you will never accept. That's what we money got. So you have to be very, very careful. So quality is very, very important. And I had a unique opportunity to set up the quality system for device industry. So quality is very important. And the outcomes, we said, you have an empowered surgeon. He knows what he's going to do, what he's going to see, what he's going to do. And we have patient who knows what's going to happen before we do. So when the surgeon says, do this, don't walk for 5 days, after 5 days, he's going to listen because he knows he does not listen. So we have an empowered surgeon and educated patient, better And in one surgery, no surgery is done by understand the difficulty in the different communication. Surgeon down before reimbursement does not happen now. Not only here, it doesn't happen in India. We are collecting a lot of data. That is where we look into the computer scientists and the data analysts to give us more information so that we can take it to the stakeholders who are the insurance people to say that this does have benefits. Though there is an upfront cost, the benefits outweigh the upfront. So the things that standardization is very essential is happening the last about 10 years. And I've been a part of the ultimate manufacturing standard collaborative in doing that 1, 2, and 3. Because of the medical side, I've been the chair and future for 12 years. Some research interest to ponder human. Think about all of this. How you can help. Structured reporting, which is very essential. Even a test on color. Now the radiologist is for it. A radiologist is like something. B radiologist is like because they're writing a story, writing it in their own book. It's not like so there is an opportunity for people. Now with all this automation coming in, it's like time for us to go and use AI, machine learning and see. These programs can get into the X-ray machines and stuff. So when they see the X-ray, they can say. These are all the highlighted points for the radiology. And that can be right now. Any hospital you can have to that the big part. Simulation of human tissue, desktop, understanding that faithful government. Your model is off by 3 meters or 5 meters off. From making an in summary, we have seen how enhanced visualization helps us in doing vertical reversal, intraocular guidance, correct or appropriate. You are rather than doing this, it doesn't give me 3.5, doesn't have to be. We have your inventory before you go into something. So open the have a confidence that you have a partner applying for your patient. These are some of my challenges. Thank you all for very patient listening and apologize once more for all the delays in starting. Any questions I can answer?
Any questions from the participants? Any questions, any queries?
Thank you all.
As a token of our gratitude, I request Dr. Nanducharya, Principal R&D Engineering College, to honor our resource person. The certificate and a memento. Thank you, sir. Thank you, ma'am.
Thank you so much.
Kind request for all the online participation. Online participants, we will now leave for break, and after half an hour, we will be back. The message is for online participants. Thank you.